Hello, everyone. Thank you for coming on board another time in the pizza truck. So right now, remember, if you have any questions, we have 5 minutes at the end. You can submit your question in Slido, Pizza Room. With us today, we have Pietro and Joanna from Octomoon Technology that are going to talk about AI explainability in the medicine field. So welcome, and the stage is yours.
Thank you, Stefania. Good morning, everyone. My name is Pietro, and here with my colleague Joao, we're going to talk about AI explainability and how to bring life and motion, as we call it, into the field, specifically related to the clinical setting. So we stemmed all this project from another project we're working on related to estimating the likelihood of progressing into chronic kidney disease for patients. So just a bit of background. First of all, we come from a company called Optum. We are part of United Health Group, and we are a multinational company that works in the domain of clinical services, health services, and health insurance. And the project we're going to talk about is, as I mentioned, a project to estimate the likelihood of patients that have a chronic condition in the specific chronic kidney disease, and we were trying to estimate which of these patients had a high likelihood of progressing from a stage that's more manageable to a stage that's more severe, so that we can take actions in order to prevent that. Well, so that the clinicians can take actions in order to prevent that. As you can imagine, being in the clinical domain, there's a lot of extra requirements that we need to address. So just providing a prediction is not enough. We need to provide reasons behind it, evidence, and we need to be able to show that our predictions are deeply rooted in facts. What we're aiming to achieve with this, project was providing clinicians with a likelihood for progression. Of course, that's the main objective, but also what drives each prediction. So which features are contributing to a high or low risk score, and in what quantity. So which features are more important, and how are they driving towards a higher risk, or are they driving towards a lower risk? And that's just the tip of the iceberg. In order to be fully compliant with the regulations, we also need to be able to address what the algorithm is learning, how it's learning it, and we need to be able to surface that with visualization tools that the clinicians can use. And also, we wanted to address a very important issue when it comes to this sort of algorithms, which is trustability. How much can you trust the algorithm you can use? And we have some examples here of issues that we were facing. And I kind of wanted to go with some sort of a pop quiz, but it's not very helpful because the answers are already on the slide. So essentially, suppose that you have a model that has a very high score, whatever metric you want to use. We're using the area under the receiver operator characteristic as an example, because it makes it easy to compare across models. Suppose that you have a high score for that, like 0.9, 0.95. Is that enough? Not really. It doesn't tell you everything you need to know. It just tells you that the model may be faring better than comparable models. Suppose that you introduce an additional layer, like for example, we use a library called SHAP. I don't know are you familiar with SHAP? Anybody? Okay, I see lots of heads nodding, good. And SHAP can give us an insight as to why a model is making a specific decision across a population or across a specific inference. And we can see, for example, for a patient that has a higher risk of progressing, then features related to medications or past encounters are very important. And we can see that, we can show that to the clinician. But is that enough? Not really. We still don't trust the model. We don't know what the model has learned, how it has learned it, and whether the features that the model is latching on are relevant and important. It might also be the case that the features that the model finds are new things that we didn't know were relevant, and instead they are, but it's not always the case. And we can also use AUC, for example, and SHAP values and other features to compare across different models. And that way we can choose the best model. Can you go back one slide, sorry? We can choose the best model for the task at hand. But again, is that enough? Not really. We still don't trust the model. We can see that it's better than others in some ways, which are also fairly difficult to quantify and explain. So what we wanted to achieve was a technique that enabled us to pick the right model out of a bunch of different algorithms. And by right, I don't just mean better perform, because in some cases we actually choose to go for a model that is performing slightly worse, but for which we can get a lot more insights and we can understand its decisions better. We can see how the model has learned and how the model has found important features in the data set. We want to be able to explain the model inferences. We want to be able to figure out what the model has learned from the features and how it's using the features to generate predictions. And also, we want to be able to deeply understand how the model evolves over training, not just when the model has been trained and it's grand, it's fine, it's working, but like, how did the model go through training? How did it learn? And what did it learn? And we have a few examples of that. Joao later on will go through a deeper dive into we have a small demo of what we've achieved, but these are a couple of examples of what we achieved. In this case, we're comparing across two models, and what you're seeing is the feature importance generated by SHAP over the whole population as it evolves over training. So we're essentially training a model, stopping the training after a little bit, checking what the model has learned, resuming training, and so on and so on. And you can see these are two different models compared, and you can see, for example, that the model on the right tends to have a much more stable learning paradigm in the sense that the features that the model recognizes as important are more stable. The model finds the most important features, latches onto them, and they don't change very much across training. You see, they swap place a few times, but the top 10 features tend to be roughly the same. The model on the left, on the other hand, changes its mind very often, very quickly. You can see features appearing, disappearing, going up and down by a lot of places. And that's an indication that the model learning paradigm is not stable for that specific data set. And again, this is just an indication. It's not an automatic yes or an automatic no for a model. But it's one of the factors that we considered. Another thing that we did was try to represent the model training over time and over the data set. So what we did was we took the values for the SHAP activations that you've seen in the previous slide, because we calculate that for each inference for each model at different time steps over training. We have checkpoints, for example, at 5, 10, 15% of training and so on. And for each of those steps, we take those activations, we trained an LSTM to use those activations to recognize, to classify the model so that we can say, okay, these activations from SHAP were obtained by logistic regression, right? Then we took the hidden layer of that LSTM, we trained an autoencoder on that so that we can have a low-level representation of, a low-dimensional representation of those activations. And we mapped those activations across what I like to call the conformational space of training, which, if there's any biologists here, I'm sorry, but it's what I call it. And we can plot on a two-dimensional plane what the model training looks like in that space. We can distinguish particular orbits for each model, and we can identify models that train on similar features, models that have a similar learning paradigm, and models that go in a completely different direction. And again, going into completely different directions is not necessarily an indication that one model is better than the other. It's just an indication on what type of features the model is focusing on. And in our case, for example, we had models that focused a lot on medications prescribed to the patients, models that focused a lot on previous encounters and the diagnosis that came out of it, models that focused a lot more on procedures. Because these are all very important domains, but each model tended to focus more on one area rather than others. And we can explore these models, because as Joao will go through a demo in a bit, and you will see that same chart, which right now in a static slide looks very daunting and complex. And we have dynamic views of that. We can explore each of those checkpoints and see what the model generated and how what the results look like. We have a couple of references here, because the initial idea came from a blog post that Joao found and we discussed and expanded upon. And then we started using this type of techniques to explore our models. The main idea is to take what is a black box model, tear down the walls of the box, and change them into glass so that we can peek into the model, figure out what's going on, squeeze out all the possible information out of it on how the model is making its decisions. And I think at this point, I will leave it to Joao and our demo.
Very good, thank you. So we saw before with the bar chart animations how we can track the evolution of the feature importance ranking and understand how frequently the model is changing his mind while learning more and more about the data. So if we extend this exercise to all dimensions of visualization we can have with the SHAP values, we can see something like this. So here we have different animations showing how the explainability of an XGBoost classifier, which is a popular machine learning algorithm trained to predict severe kidney disease, changes while the algorithm is learning more and more about the data. If we focus at local importance, for instance, that means focusing on a single individual patient, we can see how both the strength and the direction of the most important risk drivers, according to the XGBoost for this particular patient, change during this constant reshuffling with more data. Again, what each frame of this animation represents is a repetitive process of, say, take 5% of the data, train an XGBoost, get the SHAP values, make a frame, now get 10% of the data, XGBoost, SHAP, frame, 20%, 30%, and so on. You put them all together, you can see this evolution of how the model is learning while he's getting more data. That's why in the beginning, it's a bit more inconsistent, but especially towards the end, when it has more maturity, it settles pretty much, at least for the top 2 or 3 most important features. At population level as well, in the second animation, we can see the same exercise, but for everyone, so all of those individual SHAP values, focus on one particular feature trained in the model, which is the lab measurement code 2160, which is the creatinine level of the patient. So we can also see how is the learning process of the algorithm towards the point of having very low information about the data while he's getting more and more information. We can also see how it interacts with another feature trained in the model, which is not in the y-axis here, but is the age of the patient. So red dots are older patients, blue dots are younger patients. So we can see that after a threshold of about 1.7 in the normalized level of creatinine, there is some interaction playing out according to the XGBoost. Other dimensions are as well are cluster analysis, so how different patients cluster into buckets based on their risk driver similarity. And the B-swarm plot, so how the distribution of those top-down most important features change through time. And again, the bar chart animation, so how regardless of the risk direction, how the population-wise most important features change and get reshuffled in this continuous retraining process. So that's good. We can understand for the XGBoost those dimensions of stability of the model explanation. But the real value of this kind of exercise comes when you start to cross-compare this with different algorithms. So we can add here another machine learning algorithm. We can add the Gaussian naive Bayes. And now we have a side-by-side comparison of those animations showing how those two different algorithms interpret the data in different ways. So one of the first things that we can spot is that at local importance, so for the very same patient, they actually give different answers about what are the most important features. The XGBoost tended to consider one particular lab measurement, which is not directly in the Y label, and the gender of the patient is the most important, while the Gaussian naive Bayes considers some procedure code and the number of doctor visits and so on. And it's also a bit more unstable. You see that, who is the most important and whether it increases or decreases the risk changes a bit more. So the SHAP values, you can understand that feature importance, but again, it's a way to understand the brain of the machine, how different decision-making strategies with different algorithms reach different conclusions. Here, for instance, we can see that both of them, they agree that overall the higher the creatinine, the higher the risk for the patient. But they have different strategies. The XGBoost settles down pretty much right from the beginning the nonlinearity pattern of this relationship, while the Gaussian naive Bayes is a bit more inconsistent. Sometimes it's a bit of a linear pattern, other times it has a negative slope in the end, or it changes the polynomial ordering of things. And when we jump to the bar chart animation, what we can see is that overall they agree not very badly on the top importance features, but one particular interesting disagreement is on this procedure code here, 83970, which you see that, especially towards the end, it considers as the most important feature, but the XGBoost doesn't even consider that at all among relevant features. So that's a good use case for the humans in the loop concept in AI, because we could bring now here a specialist, a doctor, and ask, is it the case that from a clinical knowledge, let's say, point of view, this procedure code should be the most important piece of information to consider the risk of kidney disease? If it is, it would be one extra point for the Gaussian naive Bayes, because this is a pattern that the XGBoost couldn't capture. Let's try yet another comparison. We had here AdaBoost. Again, we can see different strategies. The AdaBoost creates those sort of stairway paths, which are not even with a consistent monotonicity, so it's not even always necessarily increasing nor decreasing, and it's like stable for marginal small changes. And in the bar chart, we can see that it agrees again pretty much with everyone else with the XGBoost, but it doesn't pick here that procedure code 83970. So now it's maybe 1 point less of traceability from the signal, because other independent algorithms didn't agree with that. Right, so that's good. We can do those comparisons across algorithms, but we have here more than 10 different machine learning algorithms. It wouldn't be very efficient to pairwise compare them, each one of them. So the technology we can use is the one described before. We can use embedded representations to try to get all of those same visual insights, but on a single plot. So just repeating what we are doing here, we are doing a process of take those SHAP values that we have for each patient at different moments of data maturity. We train an LSTM to guess which model was used to train this patient. And then we use autoencoders to reduce the 100 or so activations of each layer of the LSTM to a two-dimensional representation that we can see in this plot. So some interesting things that we can see here is that, let's say, linear support vector machine, linear discriminant analysis, linear regression, they are all more or less in the same region, which makes sense. They are the more linear-ish types of algorithms. So again, if we were talking about NLP, natural language processing, like ChatGPT and so on, a common kind of exercise is, you know, get embedded representations and show that the words cat, dog, and hamster are in one region of the space, and the words, I don't know, rain, snow, and wind are clustered together. So that's the same kind of exercise, but to understand the brain of machines, so how different algorithms think different or similar to each other. And opposite from the linear models, we have the decision tree and Bernoulli naive Bayes, which also makes sense. They are the more decision tree blocky style of algorithms. The interesting thing as well, because just for the similarity on itself, you could try other mechanisms. You could use PCA or UMAP or so. But the interesting thing is of getting the path, the learning path similarity, is to spot things like this. So from the point of zero information, and here you can see that the decision tree, the Bernoulli naive Bayes, they are following more or less the same pillar. So they are all together, and after some point they diverge into different areas. So that's a way of saying that for low sample sizes, the decision-making pattern of those two algorithms are virtually the same. And only after some point they start to have more unique decision-making, which also makes sense theoretically, because the Bernoulli naive Bayes is based on a strategy of just doing a single threshold division for each feature, which is what the decision tree for a low amount of sample sizes would do, because it would be more limited on trees. And the other exercise we can do, again, on the humans in the loop concept. So again, with the toy example, let's say that a doctor, a specialist, comes here and says that the diastolic blood pressure measure of the patient should be, from a clinical knowledge perspective, the most important piece of information to assess kidney disease risk. If that's the case, we can ask to highlight here, let's reduce just to render faster, what are the regions of the embedded space that are more associated with high importance of the diastolic blood pressure measure. And we can see that, hopefully it's clear, but that this region here that we saw before, that it's mostly associated with linear style of model architectures, are more associated with high importance of the blood pressure. So again, if it is the case that the blood pressure measure from a theoretical medical point of view should be the most important factor, then we could give a preference to linear types of model architectures, because they tend to pick the signal that they should be the most important feature to consider. If we remember as well, when we were seeing the Gaussian naive Bayes, that there was one particular procedure code, the 83970, that the Gaussian naive Bayes was considering as highly important. We can also try to ask which other algorithms are also considering that important. And what we see is that, again, it's pretty much just the Gaussian naive Bayes that consider that information important, as well as some cases of the nearest centroid. So this is maybe one last point of traceability to this signal, because a lot of other independent machine learning algorithms, they don't agree to pick this signal as the most important piece of information to consider. So bringing everything together, we can enhance this AI safety aspect of the model development cycle using this kind of analysis. So instead of just considering performance, what is the highest recall or F1 or whatever, we can bring in clinical knowledge and this concept of AI explainability, consistency, and stability through time to generate a safer MLOps pipeline in healthcare. And that's it. This is our contact. Thank you.
That was a very nice sound. Okay, thank you. Thank you both, if you want to come on board. So there were a few questions about Shapley used. There was one quick question, sorry, I just have to switch to Slido up, perfect. On the model, hyperparametrics, and I don't know if you want to switch to that slide, but I can ask you straight away. Should the model hyperparameters can be changed as you train on 5%, 10%, etc. of the data? I would not fit the same model with 5% versus 100% of the data.
Yeah, for this particular exercise, the main intention was just to track net of any kind of parameter change or anything, how for the same parameters, how each of those algorithms for the same data, how they change their minds during consecutive retraining. So in this exercise, all of them, they had their own default parameters. They were kept like that. They were all being used with a normalized version of the data, so that some algorithms couldn't get an advantage of being better at unnormalized data and so on. So the focus was just to get everyone having the same kind of source data, how their evolution of learning changed.
And if I may add one thing on top of that, like the idea is quite interesting, but you would lose the ability to compare directly what the model looks like across training, overtraining. So if you train a model on say 10% of the data with a set of parameters, hyperparameters, and then you train a different model with a different set of hyperparameters on 20% of the data, you can't really compare them directly. The idea is quite interesting. We might explore it and how to do that, or even how to define a direct comparison between these different type of models, but they are different models. So direct comparison is kind of out of the question if we want to maintain the sense of what we're doing.
Yes, go ahead.
Please, you can come a little bit forward. Sorry, the reason for the question was, would you trust feature importance on an XG boost that might completely overfit the data? That's the question, basically. Like, if I'm training it on 5% of the data, I mean, it might completely overfit it. Would I trust the feature importance on that? That's the
in that particular exercise, they are all like, even though we are talking about, say, taking 5% of the overall data and so on, they are all had their SHAP values evaluated on a test data. So at an unseen data, always with the same dimension that the model has never seen before.
So a question perhaps connected to that. Since SHAP values monitoring changed considerably during training, what is the logic by which you can say that one variable is more significant than the others?
Well, there are many ways we can do that, but in the essence, what we're trying to do, we're not necessarily or automatically try to assess that. The idea behind what we're doing here is not necessarily to figure out which features are more important for each model at each stage inherently. It's more about trying to figure out how the model is learning and digging through the features and latching onto the most important ones. If we wanted to do something like that, we'd at least need deeper support in terms of subject matter experts. We do work with clinicians to understand all these features much better. And even working with clinicians, like I can't just go to someone and to a doctor and say, so is diagnosis code 8913-2 important? They're just looking at me like, what the hell is that? But yeah, it's not inherently part of this current exercise, but it's definitely something we could and would explore over time.
And part of this exercise also is trying to aim exactly at that, because that's exactly the point. If we can see that there are some algorithms that they are always, consistent about this is the most important features, and it doesn't matter if you keep reshuffling things, they keep giving the same answer, versus another algorithm that every time you reshuffle gives a completely different answer. That's the pattern that we want to avoid on those kind of algorithms. And this is also a point of that the embedded representation can help, because we can see that some of them, say the XGBoost, they have this sort of smooth linear pattern, which is a proxy of that stability, while others, like those ones that are all over the place, like the passive aggressive classifier, they are everywhere in the embedded space. So sometimes it thinks that it's more like a linear model, other times it's another architecture. So that chaotic pattern that we can also see visually, it's also a proxy of how unstable the model is in terms of giving for sure these are the important features.
Thank you. And yes. I think probably you mentioned a little bit in that, but as a setup of the whole process, you first do some correlation between different features in order to have perhaps some insights and then set up the explainability process.
So there is some prior work that we do in order to understand relationships between features, but that's not captured in this current demonstration, in the sense that for most of the features we have, we're actually dealing with a very sparse space of categorical features. There's only very few, well, not very few, a few thousands of features, which are still very few in the grand scheme of things, that are numerical and non-sparse. It's mostly related to lab results. Well, they're still pretty sparse, but anyway. When it comes to analyzing categorical relationships, we do some work with that, but we tend not to incorporate it immediately in this unless we're using specific algorithms that need to know data. For example, for linear models, having highly collinear variable is a problem. For tree models, not really. So it's something we take into account, but it's not captured directly into the current demo.
Thank you. So for the last question, if you have other questions, please then come forward. But it's very interesting, perhaps. How does the SHAP compute the importance of a single features with respect to the others? And also, it's going to be long. Is there a general formulation for all machine learning models? This is quite broad. And the last part, is there a general formulation for all machine learning models? Perhaps we mentioned a little bit before.
So the answer to the last part of the question is yes. The formulation is fairly generic, and it's based on Shapley values, as the name of the library suggests. But essentially, what these values represent is how the features interact with each other in a oh, the word is escaping me, in a model that's so essentially. The way they're calculated is analyzing the interaction of each possible subset of features with each other. So each pairwise, each pair of features, each triplets of features. So it tends to be a very expensive type of calculation because it grows up with the factorial of the features, of course. But the formulation takes into account for just the interaction between these features, among these features, not necessarily with what these features look like and how they're constructed. So it is a very expensive computation, but it's very generic. And it doesn't really matter what type of model you're using on top of that. It only matters as to how those features contribute to your targets.
Yeah. And this is also in their own words, if anyone wants to explore. But yeah, and stressing again, the most important thing that many other feature important strategies do not have is the fact that it's agnostic. So it doesn't matter either if you're talking about different algorithms, but either you're talking about, let's say, computer vision, like here, for instance. So you're using exactly the same technology, but applied to computer vision. So here, the AI model could identify that this animal is a dovicher, and this one is a meerkat. But why it identified that? And using the same technology can highlight because of the long peak and the pattern in the eyes, or because of the large eyes and so on, it's a meerkat. So it's all agnostic. It's all based on a game theoretic approach of shuffling around simulations of the variables, but in a way that you can have some understanding of causality and not just shuffling things and see what happens.
Okay, thank you. If you want to put it out your own contacts, I'll let you, Pietro, finish with the last sentence. Thank you.
Sorry, the expression that I was looking for earlier came back to mind. So Shapley values come from game theory, and it's essentially a competitive model that establishes the feature importance. Thank you.
Done. Thank you all. Thank you, Pietro Juan.
Okay. Thank you.
Del presentatore. Mi introduci tu? Sì, ok.
Switchiamo in italiano per chi c'era prima. Switchiamo in italiano per chi c'era prima. Va bene, con noi Alex Franzol. Scusami. Scusate un attimo, una cosa che guardo adesso. Ok. Allora, con noi Alex Franzoni. Ricordatevi di andare su Slido, trovare la room pizza per fare le vostre domande. Ci parlerà di time management e le sue perle di saggezza, qualche perle per il bel paese. Un grande applauso e a te lo stage.
Allora, grazie a tutti. Sì, non ci saranno grandi perle di saggezza, ma un po' quella che è la mia esperienza. Brevissimamente, chi sono? Sono uno sviluppatore, sono stato uno sviluppatore fino a circa oggi. Sono in fase di transizione verso una carriera da engineering manager. Sono stato fra gli organizzatori dei primi PyCon e dei primi PyCon Italia. E da un po' di tempo, circa un anno e mezzo, lavoro in una grande azienda internazionale. Ho avuto modo anche di lavorare con persone che sono state in AWS, in Google, in Facebook, in cose del genere. E dopo un anno e mezzo mi sono reso conto che sono ancora contento del lavoro che faccio, che mi trovo bene, che ho un ritmo accettabile. L'azienda in generale ha una scarsa attrition, c'è poca gente che se ne va, una soddisfazione generale nel campo degli sviluppatori. E invece spesso parlando con altre persone che lavorano con me, ex colleghi, che lavoravano con me, scusate, ex colleghi, altre persone che lavorano in Italia, tante volte parlo con loro e mi dicono guarda, io veramente non ce la faccio più. Non si lamentano del fatto che la lamentela non è quella che la paga è bassa o che non fanno cose interessanti o altre cose, però molti, non so se è capitato anche a voi o gente che conoscevate, dal periodo Covid o pre-Covid, ma anche post-Covid è durata questa cosa, sono completamente in burnout, lavorano troppo, non riescono più a gestire tutti gli impegni, non vedono più una luce in fondo al tunnel. Allora ho provato a cercare di capire che cosa mi sta piacendo del lavoro che faccio, del perché lo faccio, del cosa funziona. Ho provato a chiedere a un sacco di amici, ex colleghi che sono andati a lavorare all'estero e la risposta in generale è stata un po' questa. Che è interessante come reazione, però secondo me è un po' vago, anche perché, permettete il francesismo, io non credo che in Italia siamo stronzi, semplicemente penso che ci manchi un po' di esperienza perché non ci sono tante aziende tecnologiche specialmente grandi e quindi non abbiamo avuto modo di fare pratica. Ho provato quindi a capire quali erano alcuni principi che secondo me funzionano nella gestione tecnologica dove lavoro e che guarda caso non sono una cosa che sono inventati da me perché è un'azienda assolutamente standard, ma che leggendo libri di management o parlando nelle aziende tecnologiche che sono già stabilite all'estero o in tante aziende che hanno un settore tech ben avanzato, sono abbastanza standard. Quindi qual è l'idea? Un titolo più, come dire, meno... Un titolo più serio per questo talk sarebbe stato Scale Up senza burnout per aziende tech o dipartimenti tech. Perché Scale Up? Perché l'azienda piccola, come ne abbiamo tante in Italia, non ha troppi questi problemi. Fino a 10 persone, come azienda o dipartimento tech, più o meno le cose si gestiscono. A qualcuno può non piacere perché l'azienda piccola bisogna fare un po' di tutto, ma se qualcuno di voi ha lavorato in un'azienda grande, non so, io ho lavorato come consulente anche presso grandi grandi banche, gruppi di telefonia, società di telecomunicazioni, sembra che anche quando il dipartimento scala o l'azienda scala è molto più grande e dici ah, posso organizzare meglio, invece sia sempre un macello, anzi sembra che a volte più grande è, più macello è. Secondo me questo è un problema che è distinto dalla questione stipendi, quindi non andrò a parlare troppo di soldi perché quella è una questione trasversale di cui si potrebbe parlare per tante cose in Italia. C'è anche la questione, io qua dico aziende tech o dipartimenti tech, la domanda è sempre, ci sono ancora aziende che possono fare a meno della tecnologia? Questa è una domanda a parte a cui non cercherò di rispondere qui perché è troppo complicata. Quindi discuterò di un po' di principi di organizzazione aziendale, niente di particolarmente strano, non è quei sistemi di holacracy management, cose hipster che alcune società tendono ad approcciare, cose molto basic. È un talk banale, secondo me, per certi versi, d'accordo? Quindi se qualcuno mi dirà, non grandi cose, è possibile. Il principio uno che ho visto è il rispetto. Non so se vi è mai capitato, parliamo sempre di grandi aziende, arrivate nella sala dove fanno sales, per esempio, o dove stanno, non so, in una banca, quelli che sono veramente nella banca, l'ufficio è tipo così e nessuno si stupisce. Quando c'è un ufficio un po' carino per il lato sviluppo, viene fuori, c'è molto stupore. Lo sviluppatore va trattato come un professionista, ovvero ci dovrebbe essere parità assieme alle altre figure professionali, anche quelle specifiche del settore. E in particolare, qualcuno ha mai lavorato, per esempio, come consulente in una grande azienda dove c'erano anche figure IT dello stesso, diciamo, assunte internamente? Secondo voi eravate allo stesso livello delle figure IT interne o eravate trattati peggio? Peggio. E allo stesso modo, secondo voi le figure IT interne erano trattate come i dipendenti della banca, quelli che facevano il lavoro di banca, o erano trattati peggio di loro? Esatto, cioè manca la parità tra le figure che invece è il primo livello per arrivare al rispetto. Tante banche o assicurazioni in Italia hanno anche diverse società per assumere gli informatici rispetto a quelli che sono, non so, i bancari o gli assicurativi. Questo provoca un fastidio innato, secondo me, in molti sviluppatori per questa mancanza di rispetto. Altri lati che ho notato, oltre a quindi una parificazione fra informatici, sales, marketing o operativi nello stesso settore, è l'attenzione all'inserimento. Quindi l'onboarding è una parte fondamentale perché è dove si può vincere o si può perdere una persona. Qualcuno viene inserito in mezzo a un macello preesistente, gli si chiede di inventarsi qualcosa da fare, questo provoca spesso una mancanza nei confronti dei nuovi arrivati che vanno a non affezionarsi all'azienda per cui lavorano. Quindi la percezione di parità è quello che è un elemento caratterizzante nei lavori nelle aziende tech dove le cose funzionano. La fiducia è un aspetto caratterizzante e quello che io vedo come elemento di fiducia, oltre al fatto di avere, d'accordo, tutto il lavoro per obiettivi, una cosa su cui si discute molto ultimamente, molto di più in Italia secondo me che all'estero, il lavoro da remoto. Come viene fatto il lavoro da remoto abbastanza bene? Tutte le persone sono messe nelle stesse condizioni che lavorino in ufficio oppure da remoto. Quindi tutte le sale di riunioni hanno anche il bel sistema di videoconferenza. Uno può entrare indifferentemente da remoto, da locale. Se si va in ufficio si lavora da locale, se no si lavora da un booth. L'hardware è fatto bene, tutti gli strumenti sono adatti, Slack, Miro, Google Docs, perché il grosso problema del lavoro da remoto è quando l'azienda non fa veramente lavoro da remoto, ma se qualcuno vuole stare lontano, attacca ogni tanto un tool che non è condiviso da tutti. Per cui uno va sempre in ufficio, fa le riunioni live, non scrive mai una riga di documento per fare un sommario, e quelli che sono da remoto diventano lavoratori di serie B. Invece una cosa che è collegata al rispetto è far sì che tutti i lavoratori, in qualsiasi condizione lavorino, abbiano la stessa dignità. Se tutti lo fanno ogni tanto è più facile. Cioè, il mio VP of Engineering adesso, anche quando vado in ufficio a Berlino, non l'ho praticamente mai visto in ufficio, lui è di Berlino ma lavora sempre da remoto. Molto più facile quando anche ai piani alti, diciamo, lavorano così. Poi tutte le aziende ormai sono un po' remote se avete più di una sede. È un po' strano quello che si vede in Italia. È difficile rifiutare il fatto che il lavoro da remoto esista. Qua non so qual è la vostra esperienza, a volte si cerca di tornare indietro, il bacino di lavoro può essere quasi il mondo o almeno il continente per qualsiasi sviluppatore. Il secondo passo è l'organizzazione. La pianificazione esiste, le stime esistono come in forse quasi tutte le aziende che ci sono al mondo. Quando fate la pianificazione in Italia o in un'altra azienda, cosa si usa spesso dire della pianificazione? Abbiamo fatto una pianificazione? Come? Quello è il modello, ma tante volte ho sentito spesso nella mia vita un aggettivo. Ah, abbiamo fatto la pianificazione è aggressiva. Avete mai sentito? Io spesso sento la pianificazione è aggressiva, il che vuol dire che di solito è irrealistica o improbabile. Quello che ho notato è la pianificazione di solito viene fatta per essere realistica e gestibile a livello medio, cioè mettiamo degli obiettivi che sono perseguibili se tutto va abbastanza bene, non perfettamente, non se tutto va male. Aggiungiamo a quel punto delle cose che sono chiamate stretch goal, ovvero c'è sempre questa paura che magari qualcuno, se finiamo prima, cosa fa? Cioè, se finiamo prima, poi la gente sta con le mani in mano, figuratevi se lavora da remoto. Allora aggiungiamo gli stretch goal su diverse feature, diversi obiettivi, diverse attività, mettiamo delle cose aggiuntive che le persone possono decidere di fare se in quel momento ne hanno voglia, se il progetto sta andando bene, se ritengono a loro discrezione che in questa situazione sia perseguibile un obiettivo aggiuntivo e possa dare un qualche tipo di valore all'utente, all'azienda, a qualcuno. Come vengono considerate poi? In fase di performance review, quando si fa un po' l'analisi di cosa si è fatto in un periodo, ci si trova a discutere di cosa si è fatto. Se si è perseguito grosso modo tutti gli obiettivi normali, la valutazione è buona, qualcosa può essere andato in ritardo, non è un grosso problema. Se uno vuole essere un overachiever, come si suol dire, può prendersi più stretch goal, farne di più e in quel caso la valutazione andrà su. Ma già la valutazione normale è buona, nessuno si aspetta che tutti gli stretch goal siano perseguiti. Un caso classico del project management che ho visto in molti luoghi nelle aziende tradizionali è che il progetto, tutto quello che bisogna deliverare corrisponde al critical path, quindi nel momento in cui salta qualsiasi cosa, tutto il progetto non ha più valore. Questa è una maniera per inserire delle cose che si possono fare in più senza grossi problemi per la pianificazione in generale. E qui arriviamo a un punto che secondo me è invece critico. L'engineering manager. Voi non so se lavorate come sviluppatori o cos'altro, avete un manager? Cosa fa il manager? Cosa fa? Fa meeting, ma diciamo la sua attività principale. Budget, poi? Tirare le fila cosa vuol dire? È troppo generico. Cioè la sua tipica giornata, la sua priorità maggiore, qual è? Come? People management? Definire le priorità, ok. Ci sono alcune risposte buone che non mi aspettavo. Allora, io ho spesso molto visto il manager quello che parla col cliente, che discute a volte di cose tecniche, quindi definisce le architetture, si mette a coordinare o delega il lavoro. L'engineering manager, proprio come figura, è il punto di contatto essenziale fra il team e il resto dell'azienda e che ha come obiettivo principale, proprio obiettivo numero 1, far lavorare bene il team. Quindi effettivamente, come è arrivata la risposta, è people manager. Io l'altro giorno ho detto che adesso che passo ad essere engineering manager sarò un people manager e la prima cosa che mi è stato detto è questo. Ok, quindi l'obiettivo dello sviluppatore, dell'engineering manager è organizzare il lavoro in maniera ordinata, sostenibile e coerente. Sapete, in azienda grande ci sono 1000 persone che chiedono 1000 cose, a volte le chiedono direttamente allo sviluppatore che non sa che pesci pigliare, cosa devo fare prima, cosa è più importante, cosa è meno. L'engineering manager tira le fila di quello che viene chiesto da prodotto, supporto, vendite, tutte quelle che sono le richieste e fornisce al team una visione più o meno coerente delle priorità, dopodiché stabilisce un rapporto di fiducia con i membri del team, chiede loro come va, cosa vorrebbero fare, come vorrebbero crescere. Contemporaneamente capisce molto bene il lavoro che vanno a fare. Non è una persona che è distaccata e non ha idea della tecnica che sta sotto, ma generalmente non ha come priorità quella di contribuire al codice, ai notebook, alla tecnologia. Generalmente rimuove i blocchi per il team e gestisce tutte le pratiche che hanno un forte task switching per permettere agli sviluppatori di avere focus sulla loro attività, perché tutti gli sviluppatori sanno che hanno bisogno di concentrazione prolungata per poter andare a lavorare bene sul codice. Qualche volta qualcuno è stupito da questo approccio a questo tipo di figura che guida il team senza per forza contribuire. Vi viene in mente da qualche altro campo una figura simile? Qualche idea? L'allenatore, esattamente, l'allenatore. A me hanno detto, mentre facevo la mia intro a fare engineering manager, che l'engineering manager è un misto fra un allenatore, un segretario e uno spazzino. perché qualche volta si trova a, se ci sono delle cose da tirar su, da raccogliere i cocci, da mettere insieme cose che sono state distrutte, questo è più o meno il ruolo dell'engineering manager. È un tipo di figura che non ho visto spesso in Italia e ci manca come idea. L'altro lato dell'organizzazione è cosa fanno le figure non tech, nel senso che non sviluppano. Qualcuno lavora in un'azienda di prodotto? Ok, bene. Avete dei product manager, project manager? Avete qualche figura che gestisce il prodotto? Perfetto. E queste figure capiscono veramente bene il prodotto a livello tecnologico? Sì o no? No. Ok, questa è l'altra distinzione. Io ho notato che tutte le figure che in qualche maniera interagiscono col prodotto, che siano product manager, project manager, sales, non vanno a rivolgersi agli sviluppatori in ogni istante per capire qualcosa di tecnico, ma viceversa sono queste figure che devono impararsi molto molto bene che cosa sta sotto. Per esempio i product manager sarebbero probabilmente in grado di sviluppare qualche piccola feature sul prodotto, cioè sanno come fare un deployment, sanno come compilare, sanno come funzionano le cose a grandissimo livello. Quelli che fanno sales non sanno compilare, non si chiede di arrivare a questo livello, ma conoscono perfettamente ogni funzione del prodotto, spesso anche più di quello che va a sviluppare. Io sviluppavo in un team in cui avevamo certe funzionalità e delle volte le persone delle vendite conoscevano tutte le funzionalità più dettagliate e come andavano a integrarsi con il prodotto meglio di me. Io se una funzione non l'avevo mai toccata, io non sapevo che dire. Quindi c'è un po' un ribaltamento da le figure non tech che vanno a fare il loro lavoro come se fossero a vendere un tubo o un oggetto prodotto fisicamente, a figure non tech che devono andare a essere fortemente orientate a ciò che stanno vendendo, quindi devono conoscerlo perfettamente. Perché? Per far perdere meno tempo a tutti e contribuire meglio allo sviluppo del prodotto. E il punto terzo è quello che io chiamo separazione delle carriere. Adesso qui volevo puntare. Questo è un esempio di una tipica scala di carriere. Ho preso alcune di quelle che abbiamo noi, ma è una scala abbastanza standard. Allora, qua io di solito osservo due cose. Innanzitutto una cosa, se vedete, le figure che sono sulla stessa riga sono grosso modo figure che hanno lo stesso inquadramento a livello di stipendio. Ci possono essere piccole variazioni, ma più o meno questa è la situazione. Queste sono diverse specializzazioni verticalmente. Potete notare alcune cose, ovvero che è possibile progredire a livelli notevoli anche in quelle figure che sono cosiddette chiamate individual contributor, cioè persone che non sono manager di altre persone e quindi possono arrivare a livelli anche direttivi, potenzialmente anche più in alto. Solutions Architect, non so se è una figura che incomincia a svilupparsi anche in Italia, anche se non è così nota. Potete notare come alcune figure non abbiano la versione junior, specialmente nel management, perché non esiste il junior manager. Per arrivare a essere manager di solito bisogna avere un certo livello di seniority, ma il punto fondamentale è che non occorre mollare la carriera da individual contributor se si è bravi e si ha un grosso impatto, se si vuole progredire. Una cosa che è molto frequente, questa è una cosa abbastanza standard, non è che l'ha inventata Ivan. Andate in Google, trovate i fellow engineer, che è una scala, a livello di scala siete quasi come un vice president. Quella che è una cosa che contraddistingue ciascuna di queste carriere in verticale, che cos'è? La definizione della responsabilità principale. Cosa vuol dire? Qualcuno mi dice, sì Alan, però noi siamo un'azienda di 20 persone, non è che possiamo avere 32 ruoli. Sono d'accordo, assolutamente. Ma ognuno di questi ruoli ha abbinata quello che è la sua responsabilità numero 1. Lo sviluppatore avrà portare avanti qualche feature a livello di codice. Il manager avrà tenere d'occhio e prendersi cura delle persone. Il solutions architect sarà dialogare col cliente che ha qualche problema per proporgli qualche maniera di utilizzare il prodotto con il suo codice. Il sales avrà fare un certo numero di contatti o arrivare a un certo numero di vendite. Non è detto che queste figure poi non vadano a fare altro. Come manager, se avanza del tempo, si può per esempio scrivere codice, ma l'importante è che non c'è un conflitto tra le diverse figure per quello che è la priorità massima. Questo consente di mandare avanti il lavoro in maniera piuttosto agevole e senza dover pensare, come manager ad esempio, se devo mettermi a fare stendere un documento tecnico, scrivere una feature o parlare con le persone. Quello che accade è che se il manager fa troppe cose, poi trascura qualche altro elemento, che spesso è quello di parlare con le persone, perché sembra che si possa spingere più avanti. Sì, diciamo che l'informatica è un po' cambiata rispetto agli anni 90, all'inizio del 2000, in cui c'era il webmaster che faceva un po' tutto, no? Il webmaster era lo smanettone, le aziende facevano altro, intanto chiedevano al webmaster: ma sì, mettimi su questo Drupal, questo WordPress, questo CRM e poi faccio tutto io. E grosso modo direi che that's it, nient'altro, corto e banale.
Grazie mille Alan, secondo me invece hai fatto venire in mente 2 o 3 cose un po' di persone in cui magari non si mette così tanta attenzione e ce ne vuole. E c'è già una prima domanda riguardo all'approccio su come cambiare questa cultura IT, come hai ben mostrato. Secondo te è possibile farla partendo dal basso, sia in piccole ma anche in grandi organizzazioni, o è necessario comunque avere un input dall'alto che poi a scalare fa cambiare veramente la cultura aziendale?
Allora, questo è un talk che parte da alcune idee che avevo per un blog che non ho ancora pubblicato perché ho avuto qualche problema con la piattaforma. Secondo me il problema, come giustamente è stato compreso nella domanda, è di cultura. Cioè io ho parlato con alcune persone che fanno HR in grandi aziende, director, cose così, e gli ho detto: ma sapete che questa cosa qua non può funzionare e non sta funzionando, perché poi mi raccontano sempre tutti i problemi che hanno, organizzazione, cosa non funziona niente, quindi prendo 600 consulenti. Secondo me è una questione storica, perché in Italia abbiamo sempre avuto una marea di consulenti e quando la cultura e però poi quando si è visto che le aziende diventano sempre più tech, hanno detto: no, ma prendiamoci le persone dentro. Cosa abbiamo fatto? Abbiamo iniziato ad assumere persone che prima erano consulenti, e non vai ad avere un engineering manager per i consulenti, le abbiamo portate dentro, ma non abbiamo saputo organizzare, non sappiamo ancora organizzare una gestione interna. Quindi secondo me è proprio una questione di parlarne a tutti i livelli, cioè dal basso, ma anche con quelli che sono i decision maker, ma per far capire loro che stanno lasciando dei soldi sulla strada, cioè stanno veramente chiedendo troppo alle persone e stanno sprecando quello che è il potenziale. Io cerco di operare a più livelli e vorrei portare in giro questo blog e questo talk in altri contesti. Io sono di Trieste, stiamo cercando di farlo vedere al MIB, che è una delle scuole che offre un MBA a Trieste, quindi è necessario uscire un po' da quello che è l'ambiente dev e parlare solo agli sviluppatori. Bisogna andare un po' a parlare con quelli che sono manager, responsabili, per far capire per portare qualche esperienza, perché secondo me dare dello scemo a qualcuno non funziona mai. Io cerco qui di portare degli esempi di quello che funziona e non solo dire fa tutto schifo, e spero che sia un approccio più interessante.
E, diciamo, su questo punto come approcceresti questa discussione? Quindi magari un developer che riconosce questo problema, come approcceresti? Quale consiglio dare anche a chi magari sia il manager o a qualcuno, o a fare magari un gruppetto e poi andare insieme?
Internamente alle aziende immagino che sia la domanda.
Per l'approccio.
Questa è una bella domanda. Secondo me, se si identifica un manager che deve fare quel lavoro, è l'unica persona giusta con cui parlare, perché è l'unico che può prendere in mano la situazione. Bisogna portargli qualche esempio. Di esempi ce ne sono e spero di poter raccontare questa cosa ancora in maniera che si possa conoscere di più. D'altronde, se questa struttura non c'è, io non mi farei, io tante volte dico che è bene non farsene, cioè non piangere, la struttura non c'è, sappiamo che non è che lo sviluppatore ad essere cattivo o incompetente, cioè qualche volta se la priorità non viene data, io dico non prendiamocela come se fosse un nostro fallimento professionale, anche se è più difficile progredire senza avere una persona che dia il feedback su quello che sai fare, su quello che non sai fare. Piccolo esempio, io sto diventando engineering manager adesso, non perché fosse una mia idea, ma perché il mio manager, dopo aver visto il mio lavoro, mi ha detto: ma sai Alan, che tu sì, potresti passare a staff engineer, però secondo me hai una serie di competenze interpersonali che non sono scontate fra tutti i nerd che abbiamo in azienda, e quindi potresti fare bene questo lavoro che non è facile da trovare come figura, neanche lo sviluppatore, ma l'engineering manager con competenze tecniche a volte è anche difficile da trovare. Di solito si trova o quello che ha molte competenze interpersonali ma ha perso troppo la presa sulla tecnologia e diventa un problema separato, o quello che è troppo tecnologico e non vorrebbe in realtà gestire le persone.
Grazie, tra l'altro hai risposto anche a una domanda che era proprio su come sei diventato manager e quindi magari per una persona che vuole diventarlo far presente i suoi punti di forza in entrambe le direzioni, quindi sia tecniche sia soft skills che citavi adesso. Una domanda che hai citato questo blog post, puoi ripetere il blog, magari se vuoi lasciare i tuoi contatti
il blog,
in slide?
io vorrei chiamarlo proprio Tech and Italy, ma non ho ancora pubblicato niente, cioè sono partito col talk, ma vorrebbe, guarda, qua c'è il mio sito franzoni.eu, sarà probabilmente un sottodominio.
Ok, lasciamo quella.
Questo è il titolo, io spero prossimamente di riuscire a buttare giù i primi passi, dove vorrei trattare alcuni di questi argomenti con un po' più di spazio, un po' più di respiro. C'è anche qualcuno che mi ha già detto che vorrebbe contribuire, quindi ospitare qualche magari direttore di aziende di altri tipi che dà la sua opinione. Sì, questa è una cosa che è un po' in fiere, non è che si cambia da un giorno all'altro, ma ci proviamo.
Sicuramente l'audience giusto, quindi se qualcuno vuole aiutare Alan in questo progetto sa come contattarlo. Consigli validi anche per la pubblica amministrazione? Questa domanda.
Allora ragazzi, io devo dire una cosa, io ho lavorato pochissimo con la pubblica amministrazione e devo dire per fortuna, perché era fuori di me. Sinceramente non saprei, nel senso che secondo me è più veloce il cambiamento nel privato che nella pubblica amministrazione. Credo che sia un argomento troppo ampio per affrontarlo qui. Se qualcuno ha qualche idea, qualche problema specifico e vuole scrivermi e mi viene in mente qualcosa, posso provare a rispondere a domande specifiche, ma così non saprei come aiutarvi. Può essere utile, in tutti i casi, provare a chiedere al vostro superiore quale dovrebbe essere il suo ruolo, perché a volte c'è qualcuno che si dice people manager, quindi gestisco le persone e poi fa tutt'altro. Chiaramente se poi al vostro manager non sta simpatica questa cosa, non è bello come rapporto che viene instaurato. Devo dirvi, il mio manager, quando sono arrivato nell'azienda in cui lavoro, è, non dico il mio migliore amico, ma è probabilmente la persona che più mi ha aiutato nel mio lavoro. Quindi se il vostro manager rappresenta per voi più un problema, uno che vi sgancia le giobbe, anziché aiutarvi, c'è una riflessione da fare, secondo me.
Abbiamo finito il tempo a disposizione, c'erano delle domande molto interessanti, secondo me possono essere tutti blog post da farti scrivere, quindi se volete contribuire e fare la domanda direttamente a Alan Franzoni qua, abbiamo ancora qualche minuto di break. Ancora un applauso a Alan Franzoni e grazie a tutti.
Grazie, se avete ancora domande, ci mettiamo nella stanzetta qua oppure a pranzo, quando volete. Io sono qua fino alle 7, fino alle 6:30 di stasera io sono qua.
Direi che lì è il posto migliore, perché ci sarà un via vai qua.
No, infatti la saletta, dicevo, quella all'entrata.
Okay, welcome everyone. And it's my pleasure to introduce Refik, who is a data scientist at Aerobics. Great guy, great scientist. So today is talking about controlling the chaos, reproducible deep learning experiments using Lightning and Hydra. So welcome, Refik. If you have questions, please ask them on Slido. We will have a 5-minute Q&A at the end.
Okay. Hello, everyone. Welcome for this talk. I'm Refik, and I will introduce you to the controlling the chaos for reproducible deep learning experiments using the Hydra and the Lightning frameworks. First, I'm a data scientist in Aerobics. We are 45 people, and we are a very young team consisting the data scientists and the software engineers. We are located in Bergamo and Brescia, and we are applying the AI deep learning to the manufacturing industry, the healthcare, and also recently we are applying reinforcement learning to the games. Today, I would like to start with the happy data scientist or researcher checklist. So as a data scientist or researcher, we like to have some toolbox, which is well integrated with the Python environment, and it should have some high-level APIs for the mathematical computations. We should be able to put our experiments and the research models into production fast as possible. We should have some tools for handling the data, and if we are lucky and we have multiple GPUs or multiple computers in a cluster, we like to train our experiments in a distributed manner. For each experiment, we also like to have a logging, tracking, checkpointing the models. At the end, we like to visualize and compare the results using the performance metrics. If you don't like, we like to also try different parameters and repeat most of the steps again and again and again until we are happy. So I'd like to introduce the PyTorch, which most of you, I hope you already saw it. So PyTorch allows us to use the Python API for fast computations using the C++ as a backend, but you can easily write your own dynamic computation, and you just define your forward pass, and it will automatically compute all the gradient and the gradient computations for you when you call the backward pass. So it's built from the researchers for the researcher, and also it's very widely used in the academia and the plus the industry. And PyTorch also gives you a lot of flexibility for exporting your model to the Torch script, Onyx, Torch server, or even if you have a C++ front end, you can export it and use it in the C++. So let's start with a simple example that you may see everywhere, which is the image classification using the CFAR10 data set. So you have a 32 by 32 images, and you have 10 classes. What you want to do is classify image and find the correct class. So Torch has some classes for you to load this data, and you can specify train and set, and it will allow you to load your data in a batched manner for your training. After that, on the left, you can see that we have a simple neural network, which is a convolutional neural network. And it has the convolutional layers and the linear layers. And you define the forward pass. After that, you instantiate your class, your loss for cross-entropy, because it's classification. And then you define your optimizer, and you start training. For this case, it's only 2 epochs of training. For each iteration of the train loader, you get the data, feed to the neural network, compute the loss, and call the loss backward for the gradient, and update your weights using the optimizer step. After the end of your training, you can save, you can export, as I said, and you can see that this example fits into one slide. But however, we didn't mention about how we can copy my data to the GPU, or how I can accelerate my model inference time on the train time using the different accelerator. And also, I don't have a callbacks to do the checkpointing or logging to the tracking server. So in that case, I need some boilerplate code to improve my quality of the experiment. So there is a library called PyTorch Lightning, which is built on the PyTorch and allows you to skip all the steps and gives you some toolbox for this kind of acceleration, such as you can switch between GPUs or TPUs or another kind of accelerator you want. You can, without changing the code, you can distribute your training, and also it has the callbacks, loggers, and profiles, and many more. So if we refactor our code, we can just instantiate another data model, extends from the Lightning data model, and we have to define 4 or 5. In that case, I just give the 4 example of function, which is the prepare data will run only the main process if you are running the distributed training. and the setup will load the data set from the disk, and the train and the validation data loader will be called by the PyTorch Lightning automatically when you do the train and the validation. So we also refactor a bit of our model to introduce the training step and the configure optimizer on the left to also able to log the loss during the training. So when we call the stats.log, the Lightning will log all the loss according to your loggers instantiated. Could be MLflow, could be weight and biases, or any cloud service. On the right, at the end, we have a main function that we can introduce our arguments. We call our data modules, and we can have, as I mentioned before, the early stopping as a callback that stops the training if the certain criteria is not matched. We can log our metrics to the CSV file, and we instantiate the PyTorch Lightning trainer, and we call the trainer.fit. Again, we are in the one slide range for the code. However, so if you want to run this code in the command line, what we have to do is, okay, Python main.py, and after that, we have to pass the batch size, learning rate, and other things for the running the experiment. And this is the part where the chaos begins, according to this talk, because what happens if you want to add a different model? A different optimizer. So we have to pass as a maybe string, and then inside the code we have to instantiate. But what happens if we want to try multiple GPUs or different accelerator? Like this list will go too long. In fact, if you check the PyTorch original example for ImageNet, you have a huge list of arguments that you can specify and adapt according to your needs. And sometimes maybe you want to change not only a single one, but a group of configurations. And it may be difficult because at best case scenario, you should write a bash script, many lines of bash scripts for each type of configuration group. However, in these years, because also the Python version is improving and we have the data classes that is more common, from the arguments you can go to the data classes to also have a more Pythonic way to define your arguments, but still the configuration group with the data classes is not solved very well. So Hydra is actually allowing us to do this kind of configuration group management and mix and matching the different configuration groups. Plus, we can have a subfolder for each task, and when we have the project, we don't need to define the same stuff over and over again. Hydra has also a plugin system that can have the launchers and the sweepers. So launchers, if you use them, for example, you can run many experiments in a parallel or a sequential way, depending on what hardware you have. And it will run each configuration group that you pass from the command line for you sequentially or parallel. Sweepers can find the best parameters in a group that you pass as a hyperparameter range. And again, when you run multiple experiments, it will return the most optimized parameter for your needs. Let's refactor our code again. So on the left, we have the configuration groups. And I divided into the different folders such as trainer and the model and the data. And the trainer, you can see that we have two groups, which is one of them is the default, the other one is the CPU. So in that case, for default, I use the max epochs to 10 and the accelerator is a GPU. However, in the CPU, I use the max epochs to 2 and the CPU. In that case, I can pass the trainer /default to pass all the configurations to my training and or the CPU group for the CPU training. On the right, we have the decorator from the Hydra that can parse all the configurations. And the rest of the code doesn't change too much. We just use the CFG from the config to pass all the arguments to our classes. So for this case, we can call our Python main.py and the trainer.max epochs, which will run one experiment. In the second line, we have a default and CPU. For it makes 2 experiments for training. And for the learning rate, we have 3 different learning rates to try. So at the end, this run will, with the multi-run argument passed, will run 6 experiments in total. Again, according to what you have as a hardware. If you have a single GPU, single computer, it will run sequentially and log everything differently in separate folders for you, so you can go back and check the results. Hydra can also instantiate classes from YAML files, And this allows you to, for example, define your optimizer in the YAML file. Then you instantiate by accessing the configuration from the YAML file. And if you have, for example, optional parameters or other arguments that has to be sent from the Python side, you can pass it in from the Python side. Also, you can define your own custom resolvers to hack the YAML and how it is interpreted when you run the configuration, such as if I want to return my argument as a tuple, I can define as tuple function, and then I register this resolver and I use it. Also, Hydra, since it's actually backed by the Omega Conf as a library for the YAML files, you can access the environment variables, such as if you are tracking on the MLflow and your environment has the MLflow tracking URI, you can pass it and you can access it by calling the oc.env and the MLflow tracking URL will be available. Or, for example, if the machine is shared by multiple users and you want to share this code and maybe the data will be also in the different paths. So instead of using your own actual home folder, you can just pass the home parameter, so it will be adapted for every user. So let's revisit our checklist. So far we talked about how we can improve these happy data scientist needs. However, in the real world scenario, we need something more. So for example, there are many repositories nowadays that can publish state-of-the-art models. So we want to have some repository by ourselves that can import the different repositories if there is another state-of-the-art. For example, another classifier model, and I want to try and compare with my own classifier models without changing much code. And also, I like to reuse my toolbox, such as my modules or classes, every time I create a new experiment. I want to make all the experiment reproducible. So if I'm in a team, I want to share all the YAML files or the configuration files, all the code, plus maybe in the Git versioning, the commit hash or branch that I was using in a packed way. So I can say that, OK, take these configuration files and the code, and you can reproduce the same experiment. So we introduced today the Quadra, is from our internal library, and today is a public. And it gives you some receipts as a configuration files. So let's assume that it's also the lunchtime is coming. Let's assume that we like to cook something for the lunch, and the Quadra will give us some receipts. So in the Quadra, we have a configuration folders in a sub-modules or sub-folders divided by the task that we need. It could be a backbone or callbacks or trainers or transforms. And each of them is serving a different purpose. So we can say that, OK, we like to create some receipt, and now we need some ingredients. So I will go to the transforms because I like to transform my data. So what I'm going to do is resize, normalize, and at the end, I will convert into the tensors. Or maybe at another experiment, I want to add a random rotation as augmentation and resize back and use the same pipeline over and over again. So in the configuration file from YAML, we have this, for example, a default configuration that can define the normalize. And we are using the augmentations library for the augmentations, which is based on the OpenCV. A bit faster in the CPU case, and we can resize, normalize, and define our train validation test transforms defined in this file. So we can apply different transformations for train or different transformation for validation because we don't want to maybe apply the augmentation. And we have more flexibility to do all the things from the configuration files. So we have the transformation ready. Let's define our data module. In that case, I will discuss about the classification data module. And the data part is actually in the triple question marks means that it's mandatory. So it has to be defined from the user case. And we can have more customization, such as if you don't want to have some classes defined in the folder, we can skip them. And we can now stitch the transforms that we have defined before into the validation test and the train. After the data module is ready, we need some backbone as a feature extractor, for example. We can use the Torch Hub on the top example, and we can download from the Facebook Dino repository to instantiate the Dino model. Or we can use the team library, which also has many pre-trained models for for the image classification, and we can instantiate the ResNet from that library. Also, with the Quadra, you can specify if you want to use the pre-trained weights or the random weights, or if you want to freeze the feature extractor, only train the classifier part, so you can pass the freeze as a true. So now let's define the lightning module, and we are using the backbone as a model, and we attach the classifier on the top of it as a linear classifier. And here also we can define the criterion that is defined in the loss folder, which is the cross-entropy loss for this case. And if we continue, we can have a list of callbacks, such as model checkpointing defined in the PyTorch Lightning, or we can log the gradients, or we can monitor our learning rate. We can add the progress bar, or we can define how many times or which frequency the parameters, such as loss, accuracy, or another metric will be logged for the Lightning. Also, we have the Hydra folder, which we can define where these experiments will be logged. So if we are running in a multi-run manner, it will create a different folders respect to which parameters we pass from the command line. And we integrated another resolver for the Omega Conf, which it can beautify, for our case, to make it easy to read. In that case, if you run the Quadra with the anomaly detection with a batch size 32 or 64, it will create a folder that you can see that, okay, I'm using the anomaly padding algorithm, and the batch size is 32 or 64 when you go and check the experiments. Last is, one of the biggest component of this library is the task. So far, we have 4 main tasks, which is classification, segmentation, self-supervised learning, and anomaly detection. And again, the tasks are defined in the task folder that it can be instantiated. You can see that you can define your export type as a torch script in this case, or you can specify if you want to run tests after the training task is finished, or if you want to see some images, you can put the output example through to see the results. At the end, the task will do prepare the data modules or any kind of modules. Will train your train on your data set. Will test on your test set. It will export the models. It will also evaluate the model based on the exported model to simulate the real inference time. And it will create, if you want, the performance reports and visualize the results at the end. So the experiment is actually the final view that you see, which combines everything for your recipe to cook for this beautiful lunch. And you can see that you have a defaults that you can override, such as backbone, I want ResNet 18. Data module, I want to use the ImageNet classification. Data module, I want to use the cross-entropy as a loss, and line by line, it will overwrite and create your final configuration. Still, if you don't want to pass anything from command line, you can specify additional configurations in this file, and it will be the final one, so it will overwrite if it is defined before using the defaults. So this file will be understood by the Hydra, and it will load everything for you. So in Quadra, as I said, we have some examples. Let's check. The first one is the classification. When you run this line, it will run the classification task using the ImageNet data set. And at the end, you may have some images as a result folder, such as true positives, false positives, or like when the model was performing well, when it's not performing very well. For segmentation, we have the Oxford PET dataset, which is the simple example that you can easily run for 20 epochs, and it will train a segmentation model. And you can see that for the train, test, and validation, which are the performance and the results, and it will produce these images. So you can go and check for each experiment that you pass for each parameter you have specified and understand not only quantitatively, but also qualitative sense that if the model is performing very well or not. And we have also simple anomaly detection case for MNIST. Even though it's a classification data set, we adapted to the anomaly detection. For this case, it can also show if the 7 is actually not the perfect 7 and shows you where the anomaly for the 7. So okay, these are the sets and the sets of tasks. At the end, if we can run many experiments without any problems as a data scientist, we are happy, and we can just rest, relax, and wait for the results to do the final reporting, and everything will be run automatically, and we will be happy, hopefully. And the final part, maybe I want to mention the reproducibility, because each folder for each experiment, you have some another subfolders that is very important, and it saves everything that you need for the future. For example, maybe you run an experiment today and you need the results 2 months later. You can go back and check this folder, and it will have some checkpoints if you saved. All the configuration that is resolved, because the YAML files can be dynamic, so it will resolve for you, and you can see the final configuration that is passed to the Python code. And for data, we have a pickle file for your trained validation test folders, so you can check and you can load it and go and check if which image is used for the train or if it's used for the validation or test. You can have the deployment model and the logs or other images that will be saved. Also, is a metric, we save the branch that you use in the Git repository, and the commit hash for you can just to pull that commit hash to rerun the same experiment if your project is moving so fast, so you want to go back. So Quadra is available, and this is the QR code that you can check on GitHub. And these are the most important features that we are focused on, we are trying to improve. In the future, we like to also introduce the hyperparameter optimization, more tasks, more configurations, and also maybe if you want to run it in cloud, it could be even possible. And I'd like to shout out to my colleagues, Lorenzo, Alessandro, Federico, Silvia, Liz, and Luca. So this project could not be public or available if they were not there. And also today, two talks ago, my colleague Federico introduced our reinforcement learning library for applying to the games. And if you can also watch his talk, if you miss it, you can rewatch it after it is published. And you can check the GitHub repository for the examples. And thank you.
Okay, great talk. Thank you, Rafik. So while waiting for some answer, maybe I just want to ask you one.
Sure.
So we already talked about this, but still. So I'm kind of a messy, my code. So I don't know. I still don't see that benefit in having so many YAML files.
Yeah.
I can get messy. I'm not sure I can log everything if I want, every hyperparameter. So if you would say, the best case scenario, you think Hydra is most useful rather than having other tools or not having Hydra at all?
So for example, if you don't want to use a tool like a Hydra, so there are two options. One was the passing the arguments, or another thing you can use maybe a Pydantic plus the data classes could be an option, which is more Pythonic way. Also, Hydra has the option to define everything using the data classes, and it can also understand. The problem, not a problem, but maybe we are in the early cases that the YAML files can be easily hacked. So basically, you can change, adapt, dynamically do many things, but in the Pythonic way, like with the data classes, it's still in the early phases. I hope maybe we can, in the future, we can pass to the data classes instead of YAML files, because some people like the YAML files, some people doesn't like the YAML files. So far, we are we are more agile with the YAML files, even though it has some learning curve to understand what's going on. But when you understand it's so easy and so fast, you can do many experiments without even waiting or struggling. So far, YAML files is okay, but maybe in the future we can also test and if it's better or not to use the data classes as a second option, or we can give it the two options, and as a user, we can choose. Yes.
Okay, great, thank you. So sometime in the future, I will love YAML file. Okay, great. Okay, do someone have a question they want to ask in person? We do have one, sorry. in Slido. Okay, you said that there are pre-trained models in Quadra. How does it work with the download? Is it a platform such as Hugging Face or?
So far we have the Torch Hub, and the Torch Hub basically a repository can use the Torch Hub to upload their model, so we can download from that link. Usually they are served in maybe GitHub repository or somewhere else. And if you pass the repository name and it is supported by Torch Hub, we can download it. Also, we can also integrate another function that loads from the Hugging Face, because you just need one function that loads from the Hugging Face and one configuration file, all the arguments you have to pass. So we can have a Hugging Face loader, for example. It's easy to integrate and doesn't change a lot of code, because at the end you have a PyTorch model to do the training or testing. So as long as the output is the PyTorch model, it's easy to integrate. We have also the team library, which has a lot of pre-trained model, and like so far we are able to use many of them without any problems. It supports the classification or like a self-supervised learned models without we can download from there also. So far, but also it can be extended by the Hugging Face.
Easy. Okay. Great. Let's see if there is some other question. Okay, to register model, do you suggest using DVC Hydra or MLflow?
So we are experimenting with the MLflow, because MLflow has also a more like end-to-end solution that you can log, you can upload artifacts, you can also at the end of the training you can register your model. So now we are more focused on the MLflow. We didn't try the DVC yet so deeply, because also DVC and MLflow is improving their stuff so fast these days. And from my point of view, MLflow has a more like a single solution, and it's open source. We can just use it. We're already logging everything, and it's already supported. Actually, it's mainly the first thing that it will check if you have MLflow URI is available to log your artifacts, metrics, any kind of information that is required. And after that, when you upload your maybe the deployment model, it should be easy to also to register in the MLflow, so you can stay in the single solution for all the part that you need for the production. We never tried the DVC so far, but we can also check.
Okay. Okay, great. See you in your questions. So, okay, thank you much, Rafik. Thank you all, and see you at lunch.
Thank you.
Everybody, just one quick announcement. Please ask your questions through Slido. You can find the link in the schedule and search for the pizza room on there. Thank you very much. And welcome Luca Baggi, and we'll talk about to us about polars today. Thank you.
Thank you. Thank you, everybody. I'm really glad to be here. But before anything, actually, I would like to say thank you for all the people being here, also being people from Voltron Data and Pandas maintainers who also happen to be here. So don't be too hard on me. Also, thank you for developing these amazing products that I get to talk about in these talks. Another caveat, since there are people here, the title is clickbait, okay? You should know it by now, okay? Like me, I mean, come on, guys, yesterday... Yesterday, I gave a talk stating that Rust was easy. So, okay, you should expect it by now. It's in the character. So, but still, today, I would like to talk to you about polars and asking once again, for the next time, for the hopefully one last time, whether this is the end for the great data frame showdown. My name is Luca. I'm a machine learning engineer at Futura, and I'm also an organizer at Python Milano. And I would like to start by asking for you, everybody among us, to raise our hands, and then start progressively going down if we do not meet the same criteria. It's like ever, right? Okay, but not with no alcohol because we comply with the COC. So pull down your hand. Okay, how many of us had to do explanatory work? Mostly. Okay, good to know. It would be weird, right? If you weren't here for this. How many of you had to work with lots of raw or unstructured data, such as JSON files, NoSQL databases? Okay, many hands still raised. Good, good. How many of you had to do it on a small machine? I'm talking for you through a MacBook Air without gigabytes of RAM, so that's okay, but maybe not so much. How many years ago are you asking? Doesn't matter. Without the time or budget or the knowledge, to use like, I don't know, Apache Spark, for example, still like more than half of your hands. That's good. That's where I found myself in the past like 2 to 3 months because I'm working on a huge dump of unstructured data, like JSON line data from that I got from like a DynamoDB, which is a JSON, which is the AWS NoSQL database. And working through it is a pain, but it's also a pleasure, actually, because we have outstanding tools to do so. But sometimes performance comes at a little price, especially when you have to work with, I don't know, 2 gigabytes of compressed JSON turns out to be 15 gigabytes when you uncompress it. And so this machine doesn't work with it, okay? Pandas can only take you so far, and it's still quite a lot. But still, this makes us ask the question, is there something new we can do? And this was like a never-ending question since at least 2008, I guess. But today we have amazing tools to work with that, and I'm going to talk to you about polars. So today I'm going to discuss a couple of points. The first one being, wow, we released Pandas 2.0 like a couple of months ago. Congratulations, because it was an outstanding achievement that made Pandas like more compatible with the so-called Apache Arrow ecosystem. And this begs the question, right? Okay, Pandas 2.0 was coming, so why should I use polars? I'm going to try to answer these questions. I'm going to also try to tackle the question, you know, my Pandas data frame pipelines work just fine. Why should I rewrite the code? Also, it will take time to convert code from Pandas to polars, so why should I bother? And of course, if it ain't broke, don't fix it. But still, I would try to show you that you can take your Pandas workflow and effortlessly translate it into a polars workflow. And then if there is time left, I would like to show you a couple of tips and tricks and quacks to make a spoiler for people like aware of this in the context and see where polars is right now and what it needs to go to grow. So let's get started. With Pandas 2.0, we can use the PyArrow data type backend to enjoy a couple of really sweet features. For example, a more compact memory representation. Pandas was already using Arrow data types, for example, for their string array type. which makes it much more performant than it was all before, because of course, relying on NumPy, we had to use objects. Objects were just like array of pointers to Python objects, and Python objects are quite big. The empty string was around like 200 bytes before people of the faster C Python project started to work on it. But still, that is maybe not enough. So this is the answer to the question. Can Pandas 2.0 replace polars? Unfortunately, it can't, because even when it is using Arrow at its backend and all leveraging Arrow Acero compute engine, it actually is not using Arrow compute for all of the operations on Arrow data types. For example, and people will correct me if I'm wrong, but I had fact-checked this, group by operation do not support PyArrow compute. So we're still using the old block manager, and we can just like go down the sink with performance. So most, I would say some at least, operations are still single-threaded and unoptimized, whereas polars can offer you all cores by default turned on your machine, as PyArrow does, optimized queries with a lot of sweet features such as predicate pushdown and filter and optimization of all the like SIMD, single instruction multiple data operations. Also, polars though, and it's something that as far as actually PyArrow can also do, some way, is working with data larger than memory. So for example, I could be streaming, processing like 200 gigabytes of data of a Parquet file, for example, through these tiny bit laptop using polars. And also, one of the great things that PyArrow and polars also share is working with nested data types, making it a breeze to work with them. And so, yeah, you know, these are the reasons why you may be interested in using polars when you find that using PyArrow or the new data-type backend for pandas is not enough. And so let's move on to the next phase. How long does it take to pick up the polars syntax? And since we're doing a bit of Python, let me just get my attire. Okay, now we're doing Python. Okay, we're not doing Rust today. But before that, for a couple more references to compare to what I'm going to tell you, you should watch back the talk that Alessandro Molina gave yesterday on Apache Arrow. You should be watching the performance comparison that Alberto Danese made on Rust, actually polars and other data frame libraries. And also stay tuned, because right after this, actually 2 talks after this one, in this very same room, Fabio Riferi from Extreme will tell you how to push Pandas performance to the limits and optimize your pipelines. Okay, rewriting Pandas code with polars is actually easy. We can do it from the import, we can do it from the reading. You see, basically, read CSV, polars also has read CSV, read Parquet. It has read ND-JSON as well. Writing starts to diverge because you do not write to a format, but you write a format. And so far, so good. But polars has something more. Polars can also scan data types. This operation, and we will see it a bit later, returns a lazy frame. It is not a data frame that is read into memory, but is a data frame that, like, it's a memory mapping of the data underneath. It works both with Parquet files and CSV files as well, but I do not recommend you using CSV file anymore, sorry. It can also read globs of Parquet file. Pandas, of course, does already that. But if you scan them, you get sort of a memory map of like a file-like structure that contains Parquet file that match your regex pattern, for example, your go pattern. And then if you process it through your ETL function, then you can sync the data. So basically, the kind of operation that polars will do is understanding that it is huge hierarchy of files somewhere in your S3 system, for example. It can also read from S3, of course. And we'll process the data bit by bit in a stream, so data bit by bit, chunk by chunk, and then append every result of this operation to a single individual Parquet file, for example. So if you have a batch job, or if you just look streaming data from a database to, I don't know, an S3 lake, then you can have an S3 data lake or any other sort of data lake. Then you can, at the end of the day, for example, do a batch job that you can scan all of these files and then sync them into an individual one. What about other formats? Of course, polars cannot read data, cannot read SPSS. Why should it? Why should we ever, actually? Sorry for the bashing, okay? We can use pandas for that, because so long as the memory conversion, actually the cost of converting a pandas object into a polars object is quite low. especially when we're using a data type such as the data type backend such as PyArrows. So we can read anything from pandas, and using from pandas, we can build a Polars data frame. All of these operations require PyArrow to be installed in your system because under the hood, it's all PyArrow magic. Then comes the APIs. And people that have used PySpark, not me, will know it. We feel like it is much similar. And in a way, it might be more expressive than pandas, controversial take, but I get that pandas has a long tradition, so you cannot break stuff. Polars can break stuff and will break stuff quite often. We still 0.17.4, so there is a lot of room for breaking changes. And one thing that we love pandas for is its reliability. So here we go. But still, column selection can be performed in this following in many ways, actually. We can just use column names inside this select function. These functions, select, and we will see many others, filter, group by, they all serve the purpose to create a context. Contexts are filled with expressions. Expressions operate on the data. Context, and they cannot be used alone. So we always have to be working in a context. This is because inside the context, Polars actually performs all of the optimizations. We can select columns like so like using list of strings, iterable, couple of strings, tuples of strings, etc. as arguments. We can also use the pl.call selector, which works in the same way, but can be enriched, for example, to use select columns by data type, select column based on a regex pattern. Or we can use select all to get all the columns, and exclude some based on all the patterns that we saw above. So we can select all column except the data type, blah, 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 blah. And then by piping and actually by method chaining, we can use these select contents and these pl.all.exclude to perform operations on this data. And here we are. For example, I see this quite likely structure that I've been working on. Polars code tends to be verbose, especially if you like method chaining and if you like just parentheses everywhere. Sorry in advance for people noticing that I'm using a 2-space indent because I would like to fit the content on the screen. And as we see here, we have a couple of things going on. We see a new context manager called filter. We see a new context called filter, a new context called with columns that creates new columns on your data. And let's see them, for example. This with columns context contains all the new columns that we want to create. And see here, for example, that we can work with dates in a very similar fashion to what we've been used to with pandas. So we use pandas.series.datetime.doanything. We have the same structure with Polars. So we can see for both columns start and end, we can use the t.day and extract the day and add a suffix to this column, for example, to both of them. So the output of this function would be like a column called start day, end day, for example. Doing this with pandas is fine because we have a great .assign method that allows us to work with this, though it requires working with lambdas, and so in general it's fine, maybe it's just a matter of personal preference. But we will see where Polars will shine in terms of syntax, just right after this. We can also perform typecasting, and we can just give aliases, like give new names to your columns. And we can do something like we can work with strings, as we used to with pandas, but we can also work, and we have a specified syntax, a specific syntax for arrays, and mappings, which means like structs, dictionaries. And this is great because you can do something like this in pandas and in Polars. This will return a structure, a list of 2 elements. For example, you suppose that the name is like a name space surname. We can use polars.3.split with the space and fetch the first element of the array and give it the name first name. And then we can fetch the last element of the array and give it the name to this column given last name. Of course, the array methods are much more than this. It's just like a broad overview. But still, you have a specific namespace for arrays, and so you do for structs, to extract field from structs. The difference between structs and arrays being that arrays are lists, structs are actually data types like nested that you have, like, for example, a map. So you have a schema for them. So you can have you can read a JSON file that has nested folders in it. Polars will do its best, PyArrow will do its best to read it with a structure, a predictable structure, and you can fetch items from that structure underneath. You can also do filtering, and filtering is neat. It is done with this filter context, and you can do easy stuff like filtering all the values where, I don't know, the string is equal to some string, but you can also do window functions, for example. You see that pl.count will count the number of rows, for example, over this over keyword actually uses and enables you to use rolling functions, such as like in the old SQL. And this is great because you create this column on the fly and you only filter the values. You don't have to create a new one. You can also do group bys, and this is where things get crazy, and this is where actually Polar shines. We can group by. This creates a context, much like in pandas, like the syntax is very similar. We can use .ag, which is the same as in pandas, but while in pandas you have to pass through a dictionary of strings and functions, or strings if the function is like a mean. You can be more creative with Polar. For example, here we're grouping by 2 columns, and we want to apply the mean functions to both of them and append to both of them the suffix mean. In this other case, we want to get this column called a student unique identifier, fetch the unique number of identifiers of the students, shrink the dtype, because we can go down from, I don't know, integer 32 to integer 8 to unsigned integer. Polars will perform this conversion and give it a new name. Or in this other case, we just get the first value, the first occurrence of these other 2 columns. And this also works for temporal group bys, called like upsampling and downsampling, much like in pandas, where we have the resample function, we have an analog function in Polars. We can also do much more than this. Polars contains functions to show the optimized or unoptimized graph of the operation it is going to perform, because basically under Polars there is like an engine, a query engine, that builds a query plan, so optimizes the operation that you have to do to manipulate data. Pandas works only in eager mode, so operation happens sequentially. In Polars, so you have to be particularly cautious of the order of the method that you call on a pandas data frame, because otherwise you might be doing involuntarily some unoptimal operations. If you do Polars, Polars will say compile a plan and make it more even faster for you. You can also use the .profile method that will return a tuple of data frames. The first one being the result of your operation, the other one being a data frame containing the time that it took to perform each step. You can also plot this query plan, the performance profile, to see how fast or slow it was and where you should be looking at to increase performance, for example. And this is all native in Polars. There we go. Another thing, using lazy frames. As I was telling you, pandas only works in eager mode. Polars also works in a so-called lazy mode. And this is the great feature of Polars. You can be exploring data in eager mode and then seamlessly cast anything into lazy mode to perform the most compute-heavy operations, for example. And put those on, I don't know, a virtual machine with 190 gigabytes of RAM, and run that operation as your ETL pipeline. I'm sorry, PySpark people, but I mean, if you do not have the knowledge, the expertise to manage such a huge resource such as a distributed system, you can use Polars for this. And the great point of this is that it makes the ceiling for adopting PySpark or another distributed system much higher. So this is another great feature to keep costs down, for example. Unless one day we make Polars like distributed, I don't know. We will see like the old Dutchman will do. The data frame, the lazy frame syntax, actually any reading function that is using scan will return a lazy frame, but you can cast any data frame into a lazy frame by calling the .lazy method. Does the syntax changing for working with pandas data type, for Polars data types and data frames when you use a lazy frame? Absolutely not. What changes in the end is that if you want to fetch the result of the operation on a lazy frame, you just have to call .collect at the end, or you can sync the results to a Parquet file, for example. So this will mean that it will never have to read the whole data into memory. It will just read bit by bit the pieces that it needs and then flush them into a Parquet file. Other things, we all know DuckDB. It's a wonderful framework. I wouldn't call it Polars on C++, but you get the gist of it. They claim to be the new SQLite for data analytics, and they're a wonderful framework. They allow you to use a lot of old SQL, or Squeal. I think this is called, that's the name of the language. I don't know it very well. I think it's called Squeal. You can use Squeal syntax on working with data frames. You can do that with Polars as well. Since fairly recently, I would have to say. There are some limitations, but you can use a SQL context to, I don't know, read existing Python data frames or like Polars data frames or lazy frames into the context, and then use the context, for example, to query your dataset. For example, here we're reading a data frame using read CSV. If it was big, you could use those like scan CSV. And then we can register in the context all these objects globally. For example, basically what will happen is that all data frame objects will be read into the SQL context and will be available basically as tables for you to use. You can create tables, but actually it's easier to return data frame object and then start working on them. And we can switch on and off between lazy and eager execution inside the SQL context as well. And there we go. You can use SQL on a Python, inside your Python script. Maybe you're more familiar. Maybe you have somebody else using that. Maybe you're just working with your data analyst and they don't have the time to dig into the nits and bits of polars. They can also use this solution as well. Finally, polars can also quack squeal from the command line. This is a bit hardcore, okay, bleeding edge, really. For those who really want to bleed, we can build from source, like clone the repo, cargo build, whatever. Sorry, you have to use a bit of Rust for that. Sorry, it was not like 100% Rust-free, but I kept it. And then we can call polars, and this will basically spawn a CLI, like a REPL, where you can call SQL, basically, and a bit of polars function, let's call it in this way, to work with your data from your CLI using SQL syntax, for example. That's basically the same thing that DuckDB does, but like DuckDB at first was really well known for this, and Polar like basically closed the gap with this. I wouldn't call them interchangeable right now because they have different statuses, especially with respect to Apache Arrow, but still, it's good to have them. So you do not have to juggle between both of them, for example, if you prefer one over the other. And you see that as a result of the operation, you get nicely ASCII formatted tables, which are nicest to read, and also you see that report the data type of the objects. And you see here, for example, that the calories column is an integer of 64 bits, then we can also use it like a more compact structure, calling, for example, shrink data type, and make this an unsigned integer of, I don't know, 16 bits, because we expect it to be this be greater than 0. And we can also just use echo and like bash scripts and use the pipe operator to flush everything into polars and have polars return the same result. I would guess that this is pretty much the end for what I wanted to tell you. So I'm open to questions. Please don't be too rude. I hope I can answer your question. I think I will put down my scepter and ready to answer all of your curiosities about polars.
Yes, we have several questions. Is there a performance benchmark between pandas and polar?
Yes, there is. It is called, so DuckDB took back the old H2O.ai database, data frame performance query, blah, blah, benchmark, and they're running it, and it takes like quite a long to run, but they have updated results up until the latest minor version of Polar, which is like 16 point something. We're now in the 17 point something. And so you can see a compared performance of DuckDB, Polar, PyArrow, and a lot of data frames. But if you want to look to more like down on earth comparison, you can watch back Alberto Danese's talk of yesterday's on this. To my personal experience and some other people that are using Polars in production, there is. And it's huge. And I personally found myself extremely useful when you have to stream through datasets. I can just, I myself found out that I couldn't read a nested JSON line file with polars because there are some things that the expectation from the data structure that are not met. I can use pandas with its chunk JSON reader, so which basically you read the JSON, but you can return like chunks of JSON at a time. I read those with pandas, transform them immediately into polars after a small ETL to get the columns that I need, and then I perform the heavy lifting with polars and sync everything into an individual table. And this is really great in terms of performance because I/O happens on a multi-processing level, and all the other operations do as well.
Thank you. Concerning pl.scan functions,
yes.
Do you know about plans to add the scan SQL function as well? As far as I know, so far there is only read SQL function, unfortunately.
Yes, I agree. As far as I know, Polars does not have a scan SQL, for example, or scan database. So the point is, if you just do read SQL and then add a SQL query and then pass a connection object, the whole data resulting from the query will be loaded into memory. So if reading a huge database, you have to be cautious about that. There is no option currently to scan a database.
Thank you. When creating expressions, I saw a number of attrs like colfu.r
Yes,
struct.
yes.
Can you elaborate on their role?
Yes, basically, as in pandas, all the functions that work on arrays, structs, strings, and datetime objects are collected under an individual namespace, just for make them easier to use, easier to read, the documentation easier to find. These DT bits, from a practical point of view, only serve the purpose to say, okay, if you're calling dt dot something, it's a function that works on datetime objects. If you're working with strings, it's like this, okay? You can add string.replace, string.split, rpartition, strip white characters, and all the stuff like that. It's basically a way for expression, both in polars and pandas, to denote that they work on that specific data structure, that being data types, lists, datetime objects, strings, lists, etc.
Thank you. I see you can use lazy eval on Polar's df data frame.
Yes.
From pandas data frame. Will this limit the data size to the size of memory, or there is a smart way of avoiding the constraint?
No. If you turn something into a lazy object, that object already exists into memory, so no performance, as far as I know, no performance, no optimization on memory consumption is made. If you are converting a pandas data frame that uses NumPy as backend, it will automatically perform the conversion to PyArrow-backed arrays. So you will ideally get some performance gains because you have a smaller data structure, but that object already exists as a data frame, so casting it into a lazy one doesn't change anything. What changes is that from that point on, all the operations will benefit from query optimization.
Thank you. Do you know about Kafka Polars integrations?
No, unfortunately. It would be lovely to.
Perfect. Your example on filtering show sorting data before filtering it. Yes. Is it the kind of things Polars can automatically optimize? Is it better to sort after?
If you're working on a lazy data frame, these kind of operations are optimized. So don't quote me on this, but it doesn't really matter. The reason why I sorted here before doing the filtering is that I wanted to perform the rolling function, so count over. We're already having the sorting done, because I was not sure. I believe that I was on the Polars Discord. It's quite active. Hope to you can go there because it's a lot of people explaining, sharing stuff, benchmarking stuff. There is no way to say as in SQL rank over order by. There is not a native way for doing that yet, as far as I know. Maybe they implemented like in yesterday's release or something like that.
Thank you. What about UDFs? Can they lazy evaluated through Polars?
So Polars and as such as like pandas as an apply function, but as it is with pandas, you shouldn't be using that. So you can define a custom function. I don't know, for example, you have to, I don't know, group by and then apply a function to compute, I don't know, pairwise distances and stuff like that, using a function from, I don't know, SciPy. That can be done. You won't get all the benefits from using Polars query engine. So you can say column.expression.apply and pass a function. You can use UDFs, but it's not optimal in terms of performance. Of course, if that's the only way that you can work it out, then you can do. You can also perform a group by and create a group by context. And then basically this, if you just had raw.groupby, it will create, basically, you can use it as a context manager and then iterate over the groups, for example, then apply the function to group. But in general, it's not recommended to use apply function and UDFs. Just find a smarter way to use the existing Polar syntax if you can.
Thank you very much.
Thank you. If you have other questions or feedback, feel free to email me or scan the QR code if you want to connect with me on LinkedIn. And do not kill me, right? But still try to do my best. Thank you. We're wonderful.
Hello, everybody. Just a quick announcement. As always, ask your question through Slido. You can find the link on the schedule. It's a pizza room. And welcome to Mario. We'll talk about social network analysis in Italian Parliament. Thank you.
Thank you, thank you. Welcome. Do you hear me? Yeah, perfect, perfect, perfect. Thank you for being here and filling the gaps of my loneliness of today. Social network analysis, Italian Parliament, or what went wrong in your life to be here on Sunday afternoon. I know it's hot outside, and Florence is a good city, and I will try to convince you that it's a good talk. So I work for Open Police. What is Open Police? It's a no-profit foundation, independent, that collects data, analyzes data about the governments, public administrations, and parliament, and all the staff, organization, people related to civic organization and stuff. It's from 2007, 2006, roughly, and the core of this organization is data journalism, but also some products are more oriented to advanced data analytics. I don't want to say advanced, but data analytics more related to something that maybe here you can understand and get. So what we do, open data web application, data journalism activities, data analysis, and the core of this organization is to promote transparency, good public practices, and activism. It is known that here in Italy, but I don't know outside in foreign countries, there is few knowledge on how to transmit data from governments, from public administrations, because data is not consistent, data is not updated. Each organization has its way to store data, and even talking about the same thing. So some ministry has its way, other ministries had other ways. So we try to filter this information and make it available to the people, to the civic organization that on top of it can do other analysis and insights. What are our main techniques from a technology point of view? We work with Django, especially for admin interfaces, for providing products for small companies, Neo4j for network analysis, and it's the topic of today. Gephi, I don't know the right pronunciation, for pre-analysis, always for network analysis and other stuff, including for front-end and yes, and a good makeup artist because it's really needed. Well, this landed on my mind, this joke. Anyway, some examples of products we make. We make like OpenPNR and RR.it, that where we track and monitor the next generation EU recovery plan for Italy. And I don't know if you actually know what it is. It's like funding that the European Union is giving to each countries after the pandemic era. And we're trying to monitor and the deadlines and the projects related. Open Parlamento is where we track the Italian governments and the houses, parliamentarians, and in the next days we're releasing the new version of this portal, Open Bilancio, where we track financial reports of the Italian municipalities, and our core product is Open Policy, that is where we do data journalism. Well, I'm Mario, and I do data something. You choose which one. I don't care, and I'm diligent. I switch between 2Ds, and well, actually, drag queens. I do love drag queens. Anyway, not who, but why are you here? Well, we try to pick the Italian parliamentarians and how do they vote with Django, Network X, all the stuff that maybe you already know. We try to prepare a network analysis that goes from that visualization that maps the majority and the position of the current Senate to something more like this, where you can track how people inside the House of the Senate relate through them. And I will say how we calculate this. Briefly, I don't know how many of you are Italians and how many Italians do know actually how the parliament system works. Briefly, we have two chambers on the same level, same powers. Each law has to pass with the same text, must be voted by the two chambers. And, well, actually the government is not directly nominated, but it's the President of the Republic that nominates the government, and it has to have the trust of the two houses. What is our solution for monitoring gov and parliament data? Well, actually, as I said before, we use a Django backend solution with batch tasks that runs daily, infra-daily, monthly. We developed an Angular project, not for the general public, but for our editorial board, for the data journalists, which are not used to work with SQL or the other stuff, and try to track and change data. Metabase BigQuery for pre-analyzing data. What is for our solution for analyzing data? As I said, we have the classical pattern, extract, transformation, loading. I want to focus on the, we collect many data. I want to focus especially on the data we collect for the parliament. We have public endpoints that the governments has made available. There are Sparkle endpoints, other techniques are web scraping techniques, and we then collect them. They are into a Postgres DB, and then sync with the Neo4j and the Linkurious. And here we analyze them through Neo4j as well, but today I don't want to focus on Neo4j because it's not a Neo4j conference. It's more Pythonic, Python stuff. So that's our pipelines and how this works. Well, here I want to showcase roughly how it's pretty basic. We have data about the elections, about the politicians, about the organizations, so the municipalities, the agency, public, private companies that has something related to stuff that is of the general debate, areas, votings, and we try to make this data, obviously what the government doesn't make is to do it like a consistent updated when data is available, because it's really hard. I don't know your experiences, but I worked 2 years in private companies for a consulting company and working with, maybe something more familiar. I think it's a bit harder because data is very, very shit, is very complicated and to understand and to let them speak, because the general approach is just to make the data reachable and not usable. So, elections data, yes, web scraping. What about voting data? As I said, Sparkle endpoints to retrieve RDF data. And yes, as I said, integration batch processes with models, as we have the groups inside the parliaments, the acts that are into the pipelines of the Italian system and political parties, and how do they relate amongst them. What we have done to do this, we developed some libraries. One of these is the OETL. It's something you might use, I don't know. It's a minimal opinionated, object-oriented ETL framework. It's something I find quite useful because my 2 years in the consulting company was basically doing ETL and this stuff. So I started working inside this company with this mindset. So this is a library where we developed our needs. So some extractors that are for CSV, Sparkle, SQL extractor, and so on. For example, for the SQL extractor we use for MySQL, PostgreSQL. So and for the it follows the general approach. Extract transformation. You can use a class that inherits our class base. It's pretty naive. And the loaders, the CSV, the Django bulk loader, or the Django update or create loader, if you work with the ORM of Django and like this. So we usually the approach of getting for the voting data from Sparkle endpoints through a Django update or create loader, since we use the Django as a loader. Yeah, that's the snippet of code. It's pretty easy. You have an ETL class, and you can the extractor and the loader, and use the one we find specific and customized for this approach. Another library we developed is the Django Popolo library, where actually my boss developed them many years ago. It's a Django Popolo. It's a Django-based implementation of Popolo's Open Government Data Specification. What is Popolo? Open Government Data Specification is something that some organization has said to, if you want to work with data inside the governments or something, public administration, you have to follow some patterns, like you have to have a model that is called organization. It has to have these features. So to not only to have a system that is integrated in our system, or something that could be usable for other companies that are maybe working in other countries. So we are going to the main core of this talk. Is the social network analysis briefly. I don't know how many of you already know about the social network analysis concepts, but I just want to say I don't have a PhD on social network analysis. It's something I studied during my master university degree and something I'm using during my job. So yeah, don't consider myself like someone who is a person who knows everything. But I find it very useful for this use case, for this case study. And we have nodes, we have links like friendship and so on. So that's like a network, and you have oriented, not oriented. Friendship is a link where if I'm friend with you, you are a friend with me, or if I have debts with someone, I have debts with someone. No, the other has maybe is a creditor, so it's a kind of different link, weight or weighted. What we are using here, is a one-mode network where we have just one type of node that are people, and weighted and not oriented, that tracks how people inside the parliaments somehow connected. This is just want to showcase the Neo4j because I cited it in my abstract. Yeah, some basic concepts of network analysis degree, how many links a node have between, says how many times a node is in the shortest path between two nodes, and closeness is a KPI, a metric that on average it says how much close I am to the other nodes. Okay, so here is a snippet of something we have in our databases, and it's the health system part of the health system in a region in Italy, it's Umbria. And you, I don't know, yes, yeah, you can see this is, if I'm not wrong, a private organization who works in the health system. And this is a person who has worked inside another organization. Here, that's an example of a two-mode network because we have two types of nodes. But in our case, it will be just the nodes of persons. How do you store data here? Many types, agency metric, agency list. We will use, for our case, the agency metric, so that maps if it's 1 or if it's 0, if there is a link or not. If weighted, it will be something different other than 0 and 1. So I just want to say something about how I developed this, this case study is not only think about the developing, but starting from psychologists and sociologists. And that's not something I did after I developed it. It's something I wanted to take into account while I was developing it. It's something I heard some days before about a creativity talk we had. So it's something Weber is a sociologist that worked about how human social action works, gave me some ideas on how to put it into my developing process. So I don't want to dive into these aspects of sociology, but I just want to say to you that something I found it very interesting as my developing process. So from a mathematical approach, it's very simple. First grade school, maybe, we define weight metrics of the categories a person, of the categories of voting inside the parliament. For sake of simplicity, I just cited 5 of them. Yes, no, abstain, secret. So based on our, if you has voted yes, for me is a 100% link, and where is 0.7 is F2. Two people have voted abstained. It's not as strong enough. Like I acted like a negative approach. It's saying yes and saying no. It's like more a passive approach. Just like I was absent. Why was I absent during the vote? Because we were together, we want to tell something, to tell a story about the group we're into, because we don't like how they're approaching or they're doing things. So I'm not voting or just stochastic. So it's something you have to take into account. And, this is the tricky part because, it's something very subjective and you have to tune these parameters. Yes, auto-encoding of voting people, it's a person per categories, and then, yeah, that's very easy stuff. You get a matrix of the auto-encoding for its transpose multiplied inside by this weight matrix. Yeah, I know it's very it's very naive, and we have many matrices. And we sum them through all the set of the votings, and we apply the activation function because something that has occurred like 60 days ago is not as strong enough as something that's occurring today or based on the day I'm analyzing the network. It could be also another day other than today. Yeah, it's pretty easy. Use NetworkX library and you build this with the agency matrix, and we store the attributes to this graph. Okay, so how we analyze this particular scenario? I just like to for me, it's very like when you go to do a TC in a hospital. Since the weight, everyone is linked to other because the difference is on the weight of the members. It's like we are doing layers based on the filter we want to use. So as you can see here, I'm moving my filter to see how this kind of molecule is moving, applying a particular algorithm, that is Faucher-Mann-Reingold algorithm, and see who, at a certain level, in this case, who is the person that it's like a bridge to the majority and the opposition. So. Some results on previous legislature, like the 17 on Senate, because here in Italy, Senate is some place where tricky things happens. This is like the network during the period of the elected government. Yeah, I'd just like to focus on this one. This is Lega, a 5-star movement, and it's really interesting because some of them from the five-star movement then eventually have moved after the day of the analysis. I'm not saying that is prediction, but just a fact that then decided to move to another party. So it's really interesting to tell a story other than predict, because I don't want to say this. That's Renzi era, and yeah, that's how the network was then. What about the current legislature? We have the right wing of the parliament, and the opposition which is 5-star movement and central left wing. And this is what you have seen before, and it's pretty interesting for our journalists, because there is a party which is called the Italia Viva, Calenda, and so on, and there is the debate stating if it's like an hanger or crutch of the majority. Are they helping them somehow, somewhere? Don't know why. Well, here you can see how this position. It's on the first line, so closest to the majority. You have this party. Then backwards you have the 5-star movement, and then here you have the Democratic Party. So. As I said, I'm not talking about very hard stuff. It's something that we find very useful for us to tell a story. You cannot say that they're helping them. It's just something that is on the set of the things that help data journalists. It's not only related on data. It's also with data and with the knowledge of the argument you have. And it's pretty interesting, as long as you go higher with the filter, how the two sets, the two molecules, I like to think of it like a chemistry, biological approach, how they move. And you can see the opposition is like, here, it's like the Azione Italia Viva Calenda, it's a party from center, left center. I don't, okay. And they're moving away, and the Democratic Party and the 5-star movement higher. The Calenda Renzi party, the one I said before, has gone with a set, and the other two parties are like mitosis, meiosis. I don't know if you know how we were born. And it's different from the majority that is moving like a unique entity. And that's what's pretty different from the previous legislature, where inside the majority you have different, you have like latent in groups, individuals that are shown through the votes. So my conclusions is, as I said, majority seems to move like a single entity. Now, you know, it's the first year, so it's something maybe you can see after some time. Well, we'd like to do, we haven't done yet, is to see it like a dynamic approach. So during time, that's very interesting and more challenging. And another problem is the filter, the upper bound of this filter is going to infinite, it's endless. So we have to find something that standardizes these metrics, because each day we had new votings. So, thank you, and I'd like to say we all born naked, the race is data, now I can quit my job.
Thank you very much. I have a question about what's your favorite takeaway, like not opinion, like what have you, the pattern you have seen in all the data you gathered, you analyzed?
Do you mean what I've seen in this particular case?
Yeah, in this
so
particular case.
something interesting. Yeah, something interesting maybe is the people were inside a group is called a mixed group. Okay, so once you, inside our database, we have like a field who says who is in the majority, who is in the opposition. It's based on how they voted in the trusting votes. But you can see someone that has not given the direct trust on the facts is closer to the majority than others, than the opposition, which we might expect to find this person.
Thank you, really cool. I have another question here, but there is someone in the room.
I wonder, when you share this analysis with traditional journalists, how are they perceived by, I don't know, traditional newspaper journalists? Do they perceive the value of this data approach? What's the reaction?
No, the reaction is pretty good, because they already work with networks. So we have something that's called power maps. So it's very specific to some topic, like nominees of public agencies. And so we, in the article, we showcase the networks through Linkurious. That's the tool we use as a tool for showcases. So it's a foundation, it's a company that's used to work with data, and we work with data. So it's not something that find very far. So they already work with it. Now with this kind of depth, because it's something that's just no visualization, it's something a bit more.
It's all the time we have. Thank you very much.
Thank
it was
you.
Really interesting.
Posso?
Hello, everybody. Welcome. Quick announcement. Slido is the way to ask questions. You find it on the schedule, and the room is pizza. Thank you very much. And welcome to Fabio Lipreri. He will be talking about pandas on steroids.
Thank you, Marco, for the introduction. So today I want to show you some tips and tricks that I found during my career about improving a little bit the efficiency of pandas. Despite pandas is very used, during my career I saw that in many data pipeline, pandas is just used, but not in a very good way. So many times we see a very like junk food eating panda that doesn't leave his bed, very slow panda. It's the last conference of this call, we are at the last session, but if you have the patience of hearing me a little bit, just 30 minutes again, you can use I promise you that you will have some useful tool to make your panda become more athletic, more gymnastic, and more fast. Yeah, I know, what are you thinking? Why need another talk about pandas? Now we have a lot of new library, Modin, Polars, and I invite you to see two beautiful talk early in this conference from Alberto and Luca, then talk about Polars. I invite you to try Polars. But pandas has a very rich community, a lot of API, but more importantly, we used Panda in all our data engineering project, data science project. So at least we need to maintain pandas. And I believe that, yes, we can improve some function a little bit using Polar. We can maybe convert some tricky function in Polar. But I believe that with some tips and tricks, we can save a ton of headache, a ton of money, a ton of time from converting all our pipeline in Polars, for example. Let's get our hands dirty. Imagine that the New York City mayor officer have been employed you and asked you to improve a data pipeline. This data pipeline process 2.5 gigabytes of data, so a quite huge amount of data, and every row of this data set is a taxi trip from New York City, contain data on taxi trips. So we are a data scientist, a machine learning engineer, so we have a look of the data, and we see that we have a lot of rows. Every row contains a taxi trip. We have pick up and drop off date time. We have passenger count. We have the county of the New York City. We have some information about payment, and so on. This is our pipeline. So basically, they ask this pipeline compute the average speed in rush hour for every county in New York City. And that's three main steps. The first step, we read data and we filter the rush hour. They are two very simple functions, one for reading the data and one for filtering the rush hour. Basically from 7 to 10 and from 4 p.m. to 7 p.m. The second step, calculate the average speed for every trip in the data set. Is again a very simple function that takes some difference between the time, convert the trip distance in miles, and calculate the actual average speed in miles per hour. As a last step, we need to compute the actual average speed in miles per hour for every county. So again, it's very simple. It's a group by, and we calculate the mean for every county. So again, we have a function to import data and filter rush hour. We have a step for calculating average miles per hour. And we have the calculation of average speed for every borough. We run this pipeline, and we have this 51.4 seconds that like to run this pipeline with this data in computer science terms is like a geological era. So it seems that our pandas is still sleeping a little bit. what we can do. Let's start from the first very row. Every data scientist, every data pipeline have this row as the first row in the system. Now we are reading a CSV, and we take some time, like 17 seconds. But it's not only a matter of time of computational efficiency, but it's also a matter of memory. We have a 2.5 gigabyte data set, but once imported in Pandas, we occupy 6.7 gigabyte of memory. What can we do? Yes, we can do something simple. We can exclude the column that we don't need for the calculation. It's a very simple thing, but in many pipelines it's forgot. And we just import everything. And we save a lot of memory, of course. But still we have some problem maybe with the date type. Because yes, trip distance is a float 64. Yeah, that is correct. But we have 3 columns that are pick up date time, drop off date time, and borrow. There are objects. The point is that reading CSV, Pandas guessed that that this column were strings. And the only thing that it can do, because PandaHit hasn't a proper strategy for managing string, the only thing that can do is storing in a Python object and taking the pointer. And we know that Python object string is not very efficient data type, both from computational perspective and memory storage. But Panda has a proper datetime data type. So we can say to read CSV to import these 2 columns and tell the correct format. And we save 2.5 gigabyte, more or less. We have the last column, is borrow. Is a string, right? So we can keep it as an object. Here we can use categories. Basically, we can leverage a domain knowledge about this data. So what we know about this data is that they are string, yes, but they have a lot of unique repetition inside this column. So we can use categories. What Pandas does using categories is basically saving the unique string in a separate memory area. And they make an indexing of the string, so can keep in the column just the int value associated with the string. Converting that column in category, we save a lot of space. Now we are occupied from 6 gigabyte, 298 megabyte. So we will talk later better about Apache Arrow, but for now, let's say that Pandas have different engine to read CSV. And in this case, I'm telling to Pandas to use PyArrow engine instead of default Python engine, and it's very efficient in reading, in computational performance reading a CSV. And we save a lot of time, from 15 seconds of before to 1.31 seconds. This is very fast. Yes, we optimize our read CSV, but the main problem here is that CSV is not a very good format for storing information, big data in particular. Nowadays, we have a lot of new file types, like Parquet. Parquet is a very cool library. It's a very cool format, columnar storage format that have a lot of compression mechanism to store efficiently stuff in the disk, and also can keep meta information about your data. So Pandas or any other system don't need to guess which type our column are. Pandas fully support reading and writing Parquet. So I try to convert our taxi trip data set to Parquet, and I try to read it, and we change the order of magnitude of data reading. So we are now using just, we are taking just 157 milliseconds to read the old data set. So let's go back to the pipeline. We improve our read data calculation, and we measure again the speed. We halved the time the running time from 51 seconds to 27.2 seconds. We can do something else. We could check if the second step of our function could be improved. And yeah, the response is yes, because this, the problem of this line of code basically is that we are using an apply. And apply under the hood is using a slow Python code. What we can do about it? We can simply call average speed mile per hour function, but passing not the single row, but we can pass directly as parameter the tree series. Pandas is smart enough to understand that the operation that must perform on this series can be vectorized. So basically, they pass the data to the low-level NumPy backend, and NumPy can leverage the parallelization that basically almost modern CPU give us. Also, in this case, we save a lot of time, again, from second to millisecond. We change an order of magnitude again. So we improve also the second step. The cool thing in this case is we didn't touch the function. It was a very simple function, of course, but we didn't touch. We just changed how we pass the parameter, and removing, of course, the apply. And here we save a lot of time, from 51 seconds to 2.76 seconds, so a huge improvement. So we are happy. We optimize a little bit our pipeline. What way can we do more? What can we do is playing a little bit with the new kid in town. So from the version 2.0, Pandas can use also another D-type backend, also Apache Arrow backend. Apache Arrow is an in-memory columnar system, a library that can that is thought for big data. So I have a lot of data type, as missing data support, that was a little bit a pain in Pandas because we must define, using NumPy backend, we must define a missing data strategy for every data type that we want to use. And here we have a full support of missing data. We have improved performance. As we've seen before, is a very fast in input-output reading and writing. But I believe that the most beautiful thing of using Apache Arrow backend, I hope that in the future will be improved, is the interoperability. Because let's make an example. Imagine that some client give to you a data set in SAS, and they ask you after some analysis to write it back in LaTeX. Strange request, but still. We know that Pandas have capability as a beautiful API to read SAS and can write to LaTeX because it's a rich ecosystem. But we also want to leverage the Polar, fast, lazy evaluation, and so on. So now we can leverage the Pandas API for import and writing the data, processing the data using Polars without any copy. In particular, in the future, this will be extended, and there will be more compatibility. With NumPy backend, from Pandas and to Pandas must make copy of data, and this requires a lot of time in big pipeline in particular. So I try to import my data using D-type backend. As you can see, the data imported are the same, but we are using the PyArrow data type. And it's a huge improvement, like we remove another 1 second from our pipeline. So we are very happy. We start with the code that runs in 51.4 seconds. We optimized the import. We optimized in looping. We tried PyArrow backend from 51 seconds to 1.22 seconds. So we are happy. We run our pipeline. We get the result. And we send an email to the New York City mayor. And we are happy. We go to take a drink. The day after, the mayor replied with an angry mail that say that there are some problem on the data. There are some county that have 0 average speed. That is quite strange. We have 43 average, we have this 43 miles per hour that that is an empty county. There are some problem on data. The point is that this is a simple pipeline, of course, but in very big pipeline, detecting and tracing error is an hard task. And sometimes we can see until the end of the pipeline that there is an error, or we didn't catch the error at all. There are some tools that could help us. For example, Pandera is a beautiful library that permits us to define a schema for our data frame. And we can also check types, and we check both classical properties and statistical properties. And this is very useful. Going back to our pipeline, what I want to check here is that the trip distance is a float, and we want to check that it's greater than 0 every column. And also the borrow, I want to check that is a string, and that match some, that the string must match some character. This is a very simple regex, and that the string length is greater than 1. I can validate my data frame using the function from data frame schema, or that I believe that is more useful for pipeline. I can decorate using check output and check input function decorators from Pandera, and every time the function, in this case import and filtering, is run, input and output are checked. The cool thing about this is that Pandera raised an actual exception. So here is telling me that the string length is, that there are some problem with string length that is less than 1. They tell you in which row of the data frame he found the problem, and also an example of the problem that in this case are all empty string. So, because this is the problem. So, wrapping up. We saw that using proper data types, we can reduce memory footprint, that using category, leveraging some domain knowledge, we can save memory, in particular for using string that have a lot of unique value. That CSV is not a very good format. It's very used, but not very good. We can use something else, like Parquet. Don't use loops. This is, and use instead vectorization, and that the future of pandas probably will be Apache Arrow, and then we can use right now the Apache backend, and probably the pandas maintainers and developer will work in the next month, in the next years to extend Apache Arrow to many other API and so on, and this is very cool. And that Pandera can save a ton of EDH detecting and debugging error and making error handling on complex pipeline. But before I say goodbye, one more thing. How many of you see this warning using pandas? Yeah, almost, yeah, many people, because it's a very popular warning. Why this happen? So also expert panda user sometimes hardly understand if a pandas operation is returning a view or a copy of the data. For example, here we have this data frame, and we have the view, and we get an item, we get a user ID column, and we put the first row of this column to 1. So I can expect that just the view variable is added, but it's not true, because also the original data frame will still modify, because pandas is returning a view. So many times pandas warn us that some operation could make something that we don't want and make this warning. But we have another tool from pandas 2.0 that is the copy on write. We can set this option, and every time a write operation is performed, with this option set at true, every time a write operation is performed, must be done on a copy of the data. So this could save us also from this problem that can cause some troubles. And so I'm at the end. I hope that this talk get you some value, and you can use these tricks to make your pandas more athletic. And you can find the code on a Colab that is at this link. And now Diego slide. I'm Fabio Lipre. I work as machine learning engineer at Xtreme. And get in touch on LinkedIn to talk about whatever you want about data science, software engineering, machine learning engineering, and so on.
Thank you very much. We have several questions. Can you open create Parquet with common softwares used for CSV?
Sorry?
Can you open create Parquet with common software used for CSV?
What does it mean?
Parquet file, I think.
Yeah, you can open Parquet file. Sorry? No. I believe that there are some, maybe some tools that open Parquet file to make a user-friendly view, but it's a binary format that compress data in binary and put in so you can double-click and open on a classical file text editor like CSV, of course. Don't know if I replied to the question.
Yes. Thank you very much. How does Pandera compare to Pandas schema?
How does Pandera? I never use Panda schema, but Pandera, yeah, I don't know because I never use Panda schema.
No problem. Does it work with the self-hosted GitHub? And when you say Dagger API, is that just in the container or a service hosted externally, i.e. on a website somewhere?
I think it's not from this talk.
Sorry, I'm so sorry.
Wrong. Yeah, no problem. No
they
problem.
put them.
No problem. No.
Yeah, someone that really like pizza, yeah.
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 I can try to reply, but it's not the correct answer.
Sorry. Do you think Pandera is a good way to execute data quality checks? What about the Great Expectations?
Yeah, definitely. There was a talk about Great Expectation, and I goes to another talk, unfortunately, but I will catch up the talk. I never use Great Expectation, but seems a very good tools. And yeah, but definitely Pandera could be used to check data quality for sure. Yeah. Also outside the pipeline, of course. Also in everyday Jupyter usage.
Please explain again, PD set option copy on write. What do you mean with write?
Yeah, basically when you every time a pandas function must write data some data, this must be done on a copy of the data. So in this example, when we do get item, pandas, before doing this, make a copy of the data, and so this avoid strange change of data around your variables.
Thank you very much.
Thank you.
Is there any question in the room that want to ask? Yeah, you have to come here, please, or.
Yeah, we have the pandas, one of the pandas maintainer, so
yeah, ask him.
I'm also very honorated.
Okay, thank you very much.
Thank you.
Sono un data scientist, non ho visto GitHub, ho detto magari.